મારો અવાજ આવી રહ્યો છે? તો પેલાનો ઓડિયો કેમ નહીં આવી રહ્યો? હા હા, એ કઈ વાંધો નહીં. હજી તો પાર્ટિસિપન્ટ્સ નથી. પાછું શેર કરવું પડશે. બરાબર. શું રેકોર્ડ જ્યારે પેલા આવે ને 5 મિનિટ પહેલા, ત્યારે પછી હું પેલી સ્પીચ આપીશ કે ભાઈ જેટલા લોકો વેઇટ કરી રહ્યા છે આ બધા ઇન્સ્ટ્રક્શન ફોલો કરજો, ત્યારે સ્ટાર્ટ કરી નાખજે. જ્યારે ફર્સ્ટ ટાઈમ દેખાય છે ને તને કેમેરા ઉપર, ત્યારે તો સ્ટાર્ટ કરી દેવાનું. બરાબર? હા. A very good evening, sir.
Hello, can you hear me?
Yes, sir. We can hear you.
Okay, hello.
Sir, so it's been time for the hackathon or a workshop to start. So let's just wait for 5 minutes more for all the participants to join.
Okay.
So while we were waiting, I would like to pass on some instruction for this workshop. Participants,
This meeting is being recorded.
Participants, please make sure that you have joined with your name following the naming conventions. It should be your actual first name followed by your last name. So please make sure that you have not joined with any nickname or your device name. We will be sharing a feedback form near the end of this workshop. Please fill the form so that we can get your certificates ready. Following the criteria of 60% of your attendance time, which means you will be considered eligible for the certificates if you have attended this workshop for 60% of its time. So it's been 10 minutes more from the time of the workshop. So it's better that we start the workshop. Sir, is it okay that we start the workshop now? So let's start the workshop by first introducing today's session. Like, good morning, everyone, every participant who has joined from different parts of the country. Commencing today's workshop, on behalf of KSV and LDRP institution, I warmly welcome everyone who have joined us in the workshop this morning. Let's have a quick intro about KSV and LDRP before moving forward towards the workshop. Kadi Sarva Vishwavidyalaya is a university established with Gujarat State Act 21 of 2007 in May 2007 and approved by UGC. The university has been the setup by Sarva Vidyalaya Kilavani Mandal, a trust with more than 100 years of philanthropic existence to provide need-based education and develop courses of contemporary relevance, to be a university of excellence by providing research and skill-based activities and training which would foster higher economic growth, and to provide education to all respective of caste, creed, religion, etc. LDRP Institute of Technology and Research, Gandhinagar, was established in 2005. The college has made steady progress during the past 16 years of its existence as a prestigious state university. LDRP ITR has long recognized its role in engineering education, generation and dissemination of useful and relevant technological, industrial, and economical development of the country. The institute has contributed in the application of science and technology in the service of society through different programs of international aids and assistance. Break the Barrier events is a compilation of various interactive workshops from industry experts, working professionals, experienced developers, CEO, and more, where one can present your revolutionary idea and skill up through a competitive environment presented by the hackathon to grab the opportunity to win exciting prizing. Among the 14 plus featured workshop, today we will be conducting our Workspace and AI ML APIs plus Serverless workshop. And on that note, I would like to introduce our presenter for the workshop, Mr. Wesley Chun, a developer advocate at Google and the author of Prentice Hall's best-selling Core Python series and the co-author of Python web development with Django. Good evening, Mr. Wesley. Grateful to have you on board.
Hello, and thank you very much for the nice introduction. So I am going to do this one workshop is actually 3 separate talks. So I will be giving a break to everybody in between each talk. Each one will be about 45 minutes. And that will also give us some time at the end for extra questions and maybe a little demo if we have some time as well too.
Sure.
So, all right, okay, great. Let me share my screen and then we can get started. Okay. Okay, can everybody see the slide presentation?
Yes, sir, we can see that slide.
Yes, and the laser, my fake laser pointer?
Yes, sir, that's also visible.
Okay, great. Okay, I can say namaste, or I guess if you're from the eastern part of India, namaskara. So welcome, and thank you for coming to my workshop today. So the first the first talk is going to be on Google Workspace. The other name of this talk is Power Your Apps with Gmail, Google Drive, Calendar, Doc Sheets, and Slides, and more. I use that other title when people don't know because we keep on changing the name. First, it was called Google Apps. Then it was called G Suite. Now it's called Google Workspace. So that name always changes, but Gmail always stays the same. Google Drive stays the same. So I use that other name as well too. Just to let you know what is on this slide, I have an extra barcode. So if after this talk is over, maybe next week or maybe during the hackathon, you have some extra questions, this is a barcode and a link to an open Google Doc. I check it once in a while, not all the time, but in case you have extra questions afterwards, you can ask question, and then you can also see questions that other people ask for the other talks that I've given as well too. So I am so my Twitter is here, and I am a developer advocate at Google, and I also teach at a local small college in Silicon Valley, and I'll give myself more of an introduction here. So what is a developer advocate? Basically, we are like the funny way of saying what developer advocate means is software engineer with social skills. Okay, so that just means that we go around the world, we travel, and then we give talks to working engineers, students, professors, user groups, and things like that. So we travel around the world, and we are engineers so that we can talk to future engineers and current engineers. And my job is to enable all current and future developers to be successful using Google Cloud and other Google developer tools and APIs. My current focus is on serverless, so that's why we're going to talk about that a little later tonight, because your work, is part of your school, and then when you get into your jobs, you're going to have to write applications, and your applications have to run somewhere. And so I'm saving that one for last because that's the one that I have the most demos for, because that's my current team right now. However, I also support higher education, which is the reason why I'm speaking to you students. Most of the time, I actually speak to faculty, because faculty, it's easier for them to reach students. I can always talk to students, but you all graduate. But faculty is forever. And if I talk to faculty, then I can reach more students than if I do it by myself. That's why. And I spent about 5 to 6 years on the Workspace team. That's why I know so much about Gmail, Drive, Calendar, Doc Sheets, and Slides. But I also have been working with the AI and ML APIs on the side as well. And because I know all these different products from Google, I like to make them play well together. So I like to use, build apps that use a little bit of this, a little bit of that. And so you're getting that variety from me tonight. So when I travel, actually, I haven't been to India for about 5 years now. I think the last time I came was Bangalore in 2017, or Bengaluru, sorry. But that was 5 years ago. And then before that, it was like another 16 years before that. But I've been all around your country. I've been to Mumbai, Aurangabad, Jaipur, Delhi, Agra, Khajuraho, Varanasi. And of course Bengaluru. But I haven't been everywhere, but I've been to lots of places. So it's fun for me to come to India. Not the easiest place to travel, but the people are good. So that's why I like to travel and meet people from different cultures. It's very fun. When I am not traveling, I am making videos, I'm writing code samples, and I'm making these things called code labs, which are hands-on tutorials so that you can practice coding the things that I'm teaching you. So I will also give you links to some code labs tonight as well. And then if I have a new video I'm making, I will also write blog posts to announce it to everybody. My background in software industry is I've been a software engineer for 20 years, more than 20 years, 30 years actually. Probably the most famous thing I worked on, I was one of the original 10 engineers that built Yahoo Mail about 20 years ago. So it's pretty old now. But outside of work, I've been a teacher for longer than I've been an engineer. So it's my parallel career. And I'm also a member of the Python community. So anyway, this talk is not about me. This talk is about you. And so what I'm going to do is I'm going to give you a developer introduction to Workspace. We all know how to use Gmail, Drive, Calendar, Doc Sheets, Slides, but it's different when you code it. Actually, it's more fun because now you can just run a script and it does all the magic, and you can see it in your documents and presentations and spreadsheets. So it's pretty exciting. So this talk is broken up into these 6 sections. I'll kind of introduce Google APIs a little bit, then I'll talk more about Workspace specifically, and then I want to say something about Appscript because I think you guys will really like that. It's really easy to use, and it's actually easier than using APIs. So I'll give you that as a surprise. And then I will show you some inspiration of what you can do with Google Cloud. And some slides that I have in one presentation may be duplicated in another one because I usually don't do all 3 at the same time. But if I see something duplicate, then I will just skip over it so we have more time for other things. Okay. So one of the important things about Workspace is you first have to decide where do you want to run the code. If you want to run it on your own machines, on your own virtual machines, your hardware, your data centers, on your Google Cloud account, on your Amazon AWS account, or on your Azure account, that is your environment. You choose to you pay for that, right? Or it's what you pay for. If you want to run the code in our environment, that's what Appscript is for, because Google hosts it and it's free. It's as like I said earlier, it's I think you guys will like it better because it's higher level, it's more convenient to use. And the only drawback is there's a little less flexibility because you're doing everything in our environment instead of your environment. So you have to, if you're willing to give up some of these freedoms, and then we can take care of you better, basically. So you can either use JavaScript or a lower coding platform or a no coding platform called AppSheet, but I'm not talking about AppSheet tonight, so that's another video that you have to look up on your own. But I'm just talking about Appscript tonight, where you have to do a little bit of JavaScript. And it follows the trend. Serverless is becoming very, very popular now. So Appscript is the Workspace serverless platform. So I will tell you about that in section 4. Okay, so that's the agenda for this talk. Like I said, it's going to be roughly about 45 minutes, and then I'll give you guys a break in between so you can go to the restroom, get a drink, and things like that. So let's get started. Introduction. So what is Google Cloud? Google Cloud produces 2 well-known product groups. So, in this talk, we're talking about Workspace, but in the other parts, the other talks are going to be about Google Cloud Platform. And Google Cloud is the sort of the organization, and we basically make these 2 products. In fact, for Cloud Platform and Google Cloud, it's kind of confusing. People just think of Google Cloud as Google Cloud Platform, but just know that the Workspace team also is under the Google Cloud umbrella as well, even though we don't call it Google Cloud. Now, traditionally, people think, oh, the left side is for developers and the right side is for users, because there's Gmail, Drive, Calendar, Docsheet, Slides. But I'm here to change your mind and say the right side is also for developers, because behind each of these well-known Workspace applications that you're used to using, they all have APIs as well too. Okay, and I said earlier, this used to be called G Suite in Google Apps, and since I'm lazy, I don't want to type Workspace, I just left the URL as G Suite because it's shorter. Okay, all right. So first, a little, taking a step back. Why do we have APIs? Well, the main reason is, you know Google for all of these things, right? You know Google for search, and for YouTube, and for Chrome, and for Android, and for, Workspace. But while that's great, and it's good that Google has created this for everybody to use, you cannot wait for Google to write every single app in your whole life, right? That's a bad expectation. You should be helping. You should be writing apps too, so that you can become successful as well. So there is more to Google than just those apps. Why can't we use Google's technologies in our apps? Why do we have to do it from the beginning, from scratch? Why do we have to reinvent it? Okay, so Google has made all of our technologies, or much of our technologies, available to programmers, so that you can use our APIs to help you integrate those Google technologies into your apps, so you do not have to build it from scratch, from the beginning. Okay, so all of these icons represent a lot of our API products, so that you can use our APIs when you're building your next web app or your next mobile app. Okay, and probably both, because you can't really do one without the other these days. Okay, so that's the purpose and why we have APIs, application programmers interfaces to our technologies, so that you can have some of those features in your apps. Okay, and then if you want to, in the Workspace, if you do stuff for Workspace, you can, if you make something that's useful for people in their business, in their work, for their employees, you can put it in the Workspace Marketplace. I know this is a slightly old screenshot because it says G Suite, but it's now called the Workspace Marketplace. And if companies can download your app, instead of, okay, so if you're writing an Android app or a mobile app, you put it in the Google Play Store or the iTunes App Store, and then you hope that you go viral because you want everybody to download your apps. This is slightly different. Workspace is for companies, right? So instead of getting like 1 user, 2 users, 3, 4, 5, 10, 50, 100, you will get the number of users if an entire company wants to install your software, right? So you'll have hundreds, thousands, millions. Well, maybe not millions, maybe millions, right? Because some of these, if you look at some of these, they have a lot of installations, right? Like Smartsheet. This one has more than 8 million users. Okay. So you can go viral this way, but instead of growth like this, it's just like a chunk, because companies are installing your app instead of individual people. Okay, so you can also go viral this way too. It's not just writing mobile apps and hoping people download it, for a few US dollars each time, right? You can do this, and then you can charge support fees, support contracts and things like that, or consulting fees. Okay, so you can make different kind of money instead of small like pennies or rupees. You can have more money because now a company is buying your software. Okay, so anyway, so that's a story about why you would use and why you would write apps using Workspace APIs. Now, a lot of people have said, you know what, Google APIs is very confusing. It's hard to understand. The security, it's just it's too difficult to learn how to use. So my job is to change that to make it easier for you. Okay, that's why I have a job. All right, so now let's get started talking about how do you use Workspace and other Google APIs. The way you do it is using projects. Okay, so let's start talking about how to use APIs. So before we get to that, one important word on security. There's two big words that start with A. One is authentication and the other is authorization. They both start with auth. Authentication, people just say auth-n because it's shorter, and then authorization is auth-z. Now, what's the difference between the two? Authentication is you are who you say you are, and so typically that means login and password. But maybe you're in a more secure environment where you need to use your fingerprints or your scan your eyes. Okay, so it still determines who you are. Authorization is the next step. So let's say you've logged in. Okay, you are who you say you are, but do you have access to data? Do you have access to this spreadsheet? Do you have access to this database? So that's what it's about. It's mostly about third-party programmatic access to data. And if you're accessing users' data, those users have to give your code permission to access their data. Okay, so hopefully that makes sense. Sometimes people call this the difference between consent versus credentials. So I will let you guess which one is authentication, which one is authorization, but you should be able to figure this out. It's a pretty easy question. Okay. Oh, by the way, I know some of you will have questions, so let's save questions to the end so we don't interrupt the flow. And then maybe some of the conference organizers can help me collect all the questions, and that would be very helpful. Okay. The other thing is everybody's going to get the slide presentations, so you don't have to worry about taking a picture of every single slide. I mean, if you want to, you can, but you're going to run out of memory. All right, so I don't want that. So I'll give you guys PDF once we're done. Actually, I will probably email it to the conference organizers, and then they'll put it somewhere where you can access it. Also, at the end of every presentation, because these are shorter than my normal presentations, I actually have a link to the slide deck for the longer version of the talk, so you can download that too. It's a little older, so you can get that. You'll get more slides, but it's older. But I'll also send to the conference organizers the exact PDFs for these slides I'm using tonight. Okay, so you don't have to worry about that. Okay, so how do you get started using our APIs? You have to do everything at the Cloud Console, even if you're not using Cloud APIs. This is where almost all our APIs, you have to turn it on to use. Okay, so go to the Cloud Console. This is where everything happens. So in the Cloud Console is where everything happens. So the first thing that's important is if you are using Google Cloud, GCP, Cloud Platform, there's going to be a lot of sections. It goes way past the bottom of the screen. You can't see it. It's all the major products in Cloud Platform. If you're not going to use any of those, that's okay. You just ignore it. Okay. Cloud Platform has billing, okay, because you have to pay for it. It's like charging you money for using electricity or water or gas or your, whatever you have to pay for. You use a little bit, you pay a little bit. You use a little bit, you pay a little bit. So it has billing. Workspace is paid for by your schools, or if you have a Gmail account that's free. It's a subscription, but it's still free. So if you have a Gmail account, you can access Workspace APIs for free. If you're a company and you buy Workspace for the company, so like company branded Gmail, Drive, Calendar, Docsheet, Slides, they will get more access than a free Gmail account. You don't have as many things because anybody can get a free Gmail account, right? So anyway, so all of Workspace, the apps and the APIs, the cost is covered by your subscription. And if you have a Gmail account, then the subscription is free. If you're in a school like you guys are, and your school is a Workspace customer, then you also get that for free. So it's really just professional companies that are paying for the Workspace. So it's free. It's not like Google Cloud where you have to pay for every little bit. Workspace is completely free if you have a free account like a school account or a Gmail account. You never need to pay specifically for using Workspace APIs. Okay. If you are doing a school project and you have other students that are on your team or your group, then you would use IAM, which is Identity Access Management and Admin. So you can have 4 students working on the same project or 10 students. So it's just a way for you to organize who is working on this project with you. That's IAM. And the most important one is how to access Google APIs and turn them on and how to get credentials. So that's all done with this, the API manager. Okay. And I think I'll talk about that next. Okay, yeah. So when you click on the API manager, you get taken to this page. This is a different link. That's, the first link is console.cloud. So that takes you to like the main cloud console. If you are just a developer and you only do APIs, then if you do console.developers.google.com, then you go straight to the API manager, or at least you used to. I don't know if they changed that link or not, but the last time I tried it, this takes me directly to the API manager because maybe I don't want to do cloud stuff. So I don't want to see the cloud console. I just want to see the developer console. So that's this. Also, by the way, I made a video on how to use the developer console. So if you click on this link or visit the URL, then you can get sort of like a longer version of what I'm going to tell you tonight. Okay, or today, this morning. Because it's morning for you, it's nighttime for me, which is good. This is my best time. It's nice and quiet. It's cool at night. It's really hot in the day, like 35 to 40 degrees outside. It's pretty hot. So anyway, on the developer console, there's 3 sections that you see here. The dashboard is where you go first. That is where you view all your application statistics. So you'll see like how much traffic is your app getting, how many errors is your app generating, and what is the average response time? How fast is your app responding to your users? And then down at the bottom is the same thing, but for whatever APIs you turn on. So when you use Google APIs, we don't enable them for you. You have to tell us which ones you want to use because we have too many. We're not going to turn them on automatically for everybody because there's just too much. Okay, so in this user turned on the Gmail API, Calendar, Drive, Sheets, and YouTube Data API. So you get a list. And if you're using any cloud APIs, they're going to show up here as well too. So whatever APIs you're using, it will basically tell you statistics on how much of this API are you using, and then that relates to like how much you get billed if you're using a API that has billing. But it just gives you good information. The second tab, so that's the dashboard. The second tab is the library. So this is where you actually turn on and turn off which Google APIs you want to use. Cloud, Workspace, Maps, YouTube, they're all there. All right. You just go pick and choose, turn this on, turn this off, turn this on, turn this off. Most of them are off by default. Some of the cloud ones are turned on automatically, but if you don't want to use those because you don't want to get billed, you can just turn them off. Okay. So that's the library. Then the last one, the most important one, is the credentials. So whenever you use a Google API, you need to have some kind of application credentials in order to use it, because otherwise it's, we can get hacked all the time, right? If it's free and easy to use and we're not stopping anybody, then security is going to get out of control. So you need to have credentials to identify it's you're using this API and not somebody else. Okay, so I'm going to talk to you a little bit more about these credential types. When you go to the credentials page, it looks something like this. When you click create credentials, you get prompted to choose one of these, one of these different ones. All right. So there's 3 types. We actually support 4, but there's 3 that you can create. The 4th kind you have to create on your own. Okay. You can't, we don't do it for you. So some APIs use API keys. Not all of them do, but some of our APIs use API keys. If your API, that Google API you're using, needs an API key, then you have to click this one to create the API key to use with that API. Some APIs want a different kind. They want the OAuth client ID. If that's the case, you click that one. And then cloud APIs mostly use service accounts, so you click that one. The 4th one, which we don't create for you, is the JWT token, JWT token. That you use your own, whatever programming language you use, there's a library in that language, whether it's Python, Node, Java, or whatever. There is a library that helps you create and manage JWT tokens, JWT tokens. All right. But we don't have a lot of documentation on those, like in our console, because it's not listed here. But on our security pages in our developer documentation, you'll find some stuff on JWT tokens if you prefer those. Okay. And if you really don't know, then there's a wizard to help you choose. I've never tried that before. I just know which ones, basically, just because every API is different. So I will tell you now. I'll give you a clue as to which APIs use which credentials, so that you have an idea. Otherwise, you can try the wizard. Okay, so for our APIs, we generally recommend that you use a client library. We have different kinds of client libraries, but the majority of the client libraries you're going to use are either the low-level client library, which is found at this link, or if you're using cloud stuff, you're going to be using the cloud client libraries. This talk is about Workspace, and so Workspace is going to use the low-level client libraries. Okay, hopefully one day they'll have higher-level client libraries like cloud does, but right now they do not. Okay, I'm going to do most of my code samples in Python and JavaScript. Those are probably the most common languages as far as like web apps go. But if you're going to get a job at a big company, you're probably going to be using Java, which is perfectly fine. So, we have client libraries in Java as well. But basically, we support all major programming languages that people use in industry today. And there's probably a few that are not listed here because we're always adding new stuff. Okay. Okay. So before we move on, let's talk a little bit more about those client library types. I mentioned that we have the lower level types, and then we also have the higher level types like the cloud ones. So what's the difference? The lower level client libraries support multiple product groups. It's what we call like a lowest common denominator. The most number of Google APIs can talk at this lower level. And so if you're writing apps using different kinds of Google APIs, like maybe you're using a cloud API, a YouTube API, a Workspace API, it's probably easier if you use the lower level because they all talk the same language. Okay. If you're like only using cloud or only using Google Maps, then you should probably use the product level client libraries because these are client libraries that are created specifically for a product or a product group, not crossing different product groups. Okay, so that's the difference. They're higher level because generally the higher level libraries, you don't have to write as much code. You don't have to write as much security code. Actually, that's probably the big thing. Lower level stuff, you do have to do some security code. So we always recommend that you try and use the highest level code that you can. So if you're doing cloud, then definitely use the cloud client libraries. But like I said, Workspace doesn't have higher level product client libraries. You can only use the lower level ones. So in this case, for Workspace, you don't have a choice. Okay. So now let's talk about those credential types: API keys, OAuth client IDs, and service accounts. What are they for? API keys are what we call simple API access. This is when you're using an API to access public data that does not belong to a user or an app, okay, or a project. Such examples of public data is a location on Google Maps, like Agra. That's a pretty popular city, right? Everybody kind of knows where it is. So that's probably using a Google Maps API. And so Maps APIs use API keys. If you're uploading maybe an English sentence to the Cloud Natural Language API, that a sentence is just a string of text that is kind of public. So you can use API keys to talk to the Cloud Natural Language API. Searching for YouTube videos. YouTube videos are public, so you can use API keys to search for YouTube videos. Okay, does everybody understand that? API keys are to access public data. Now, everything else is authorized access, which means you're accessing private data. And which one of these two you use depends on what kind of private data you're trying to access. OAuth client IDs are used to access data that's owned by a human user. So that is most of the time in Workspace, because when you're accessing somebody's Google Drive files or their spreadsheet, that's data that belongs to a human user, right? So since we're talking about Workspace tonight, most of them, all of them, use OAuth client IDs. Sometimes you can use service accounts and API keys to access them too, but most of the time it's OAuth client IDs. The last one is service account, which is where you're accessing data that is owned by, a cloud project, an app, some kind of robot user. Okay, so cloud to cloud. When you are accessing data that's owned by a human user, remember what I said earlier, that human user needs to grant permission to your application to access their data. But if you're talking cloud to cloud, if I'm writing a cloud app that accesses a database, there's no human to ask for permission. It's cloud to cloud, and so that's why you need a service account. Okay, a service account is basically kind of like a robot account to make up for the lack of a human user. So that's why it's like a robot user. Okay, so that's why most cloud APIs use service accounts. Okay, so hopefully you all have a better understanding as to the differences between the three now. Okay, so again, simple API is API keys where you're accessing public data like places on Google Maps or YouTube videos. So you don't need to have authorization in OAuth. But if you're accessing, private data like somebody's files on Google Drive or a cloud API, a cloud service, a cloud database, or somebody's YouTube playlist, now that's specific, right? That belongs to a user. So you can see that YouTube is an example of providing API keys where some APIs, some services require only API key, but other services like adding something to your playlist requires authorization. Okay, so anyway, so that's kind of like sums up the difference between the two. So anyway, simple, public data, authorized, user data, or owned by a project or an app. Okay, so just kind of a quick overview as to what that code may look like. So if you're doing simple API access, it's lower level and you need an API key. So for example, searching for videos on YouTube, looking for things on Google Maps, you can, your code will look something like this. If it's Python, if it's Node or Java or other languages, it's going to be similar, but the words will be either the same or slightly different. Okay. In Python, you would use this thing called Google API Client.Discovery, and inside Discovery, there's a function called build, where you have to specify the API. So here, this is the Cloud Natural Language API, and then it's currently on version 1 of the API. And then here's my API key, which I created in the Cloud Console. And then after I was done creating it, it said, do you want to download your key or cut and paste it? You do that, you stick it in your code, but it's probably not safe to stick it in your code because your API key, you should not leak it, right? You have to protect it, because if somebody gets your API key, if you accidentally upload it to GitHub, then the whole world is going to use your API key, and then you have no more quota, or you get billed a lot of money. So you have to protect it. So only put it in code like this if you're prototyping. When you're done, you should probably put it in somewhere safe, something that's encrypted maybe, and then just have your code go and decrypt it and use it. So that you don't, give it out to the public. So please take care of your API keys. All right. You can always cancel your API key and make a new one if you make a mistake and you accidentally leak it somewhere. It's fine. You can also restrict your API key so that only apps from certain IP addresses are able to access, use your API key. So you can control the access a little bit, but when you create it just generically, it's open to the whole world. So you got to really take care of it. Okay. By the way, when you're creating the API key, it asks you, do you want to restrict it? So, you know, if you really do want to restrict it, then restrict it at that time when you're making it. Okay. All right. So that's simple. Why did we call it simple API access? Because it's simple. Authorized is more complicated. So this is where, you know, people are like, oh no, using Google APIs is too hard. But this is basically how it works. So what happens is your app needs to somehow get a valid access token. All right, a valid access token is how you talk to an API. Until you have one, you cannot talk to an API. So there's a process that you have to go through in order to get an access token. So what are they? So one, you go to the Cloud Console, and this time you select, you know, OAuth client ID or service account. Okay, this one's probably specifically OAuth client ID. You create it, and what happens is you get these credentials, and it's basically a client secret and a client ID and a client secret. You pass both of those along with your login to the Google servers and say, hey, look, this is me. These are my credentials. Look, I got a client ID and I got a client secret. They're both valid. Can you give me an access token now? And also, I don't want to ask you for this every single time I run. Can you also give me a refresh token so when this access token expires, I don't have to go through the whole routine of getting my credentials, my client ID, my client secret, and send it to you to get the access token. I want to just give you the refresh token along with some of these credentials, and you give me a new access token, so it saves time. So that's what the refresh token is for. Okay, so you do that. And then what happens is the Google server checks your credentials and it says, okay, you're valid. Here, let me give you this access token and a refresh token. So you save those in a secret place. And then when you're ready to talk to an API, you use the access token, you make the API call, blah, blah, blah. You go back and forth, make API calls. And then the access tokens expire in 1 hour. And so after 1 hour is over, if you try to use the access token again, it's going to say, you know, this expired, sorry. Then you have then the client library. So this is one reason why you want to use a client library, because the client library should take care of this for you. All right. So you just say, here's my refresh token. Please give me another access token. And the server looks at this and your credentials and go, oh, okay, you're valid. Let me give you a new access token. And you save that in a safe place. And then you continue talking to the API. Okay. Yeah, so that's step 4. And that's it, right? It just works like that. You can read more about OAuth at the link there. Other APIs will be similar with a little bit of difference. I don't know if I cover service accounts too much here, but here's an example of what it looks like when you have to do this. Okay, so this is more code because security, right? So we have some more imports. So in addition to discovery, you have to import a few other things, which will help you. So another thing that you're going to need that's new is a permission scopes. So I'm sure some of you are familiar with when you start using a different Google app or you start installing it, it'll come up with a little window that says this app needs your permission to access your Drive files, your spreadsheets, your Gmail, or whatever, right? And you have to say yes or no. That's what this is. These are the permission scopes. Okay, so now you're used to getting that box where you're the user. Now you're on the other side. You're the developer. Now you're asking your users for these permissions. So those permissions go into the scopes variable here, and they show up as URLs. And then when you call the Google servers, we take those URLs and we translate it to those words that say, I need to access your Gmail email. I need to access your files in Google Drive. I need to access your Google Docs, or whatever is the scope. So we translate those into English words, and then that's when you see that's what the box is for. So the process of doing that is, so I'm going to use, in this example, this boilerplate, I'm going to use storage.json as a file name to store my access and refresh tokens to keep it safe, okay? The older auth libraries in Python manage that for you. So I can just say stores.json is my secret file. I'm going to try and get those credentials. And if I don't have any credentials or they've expired or are somehow invalidated, Now I have to make that box show up for the user. So that is called the OAuth flow. And so this next line of code is creating that flow based on the client secret.json file. What's that? Well, remember how I said when you create an OAuth client ID, you do that in the Cloud Console, and then when you're done creating it, it's going to ask you, do you want to download these credentials, your client ID and secret? You say yes, and so you save that in this file called client secret.json or wherever you want to call it. I think by default it's client secret and some giant hash, which is kind of ugly, so I just chopped it off and just make it easy. Client secret.json. Okay, so that's my OAuth client ID and secret. And also the permissions that I'm asking for. Remember, I'm building that box that says this app needs your permission to access your Google presentations, your spreadsheets, or whatever. So I need to put all these things together. And then once I have the OAuth flow, then I want to run the flow. And that's what actually makes the box show up for your user, where it says, you know, I need your permission to do this, choose yes or no. If the user hits no or cancel, then this call to run flow will throw an exception and it does not move on. It crashes right here because you did not, you know, that user did not give your app permission to access their personal data. But if they click yes, it's okay for this app to access my data, then run flow will succeed and it will pass those credentials, basically the access token and the refresh token, to you. And then this file storage class, you see how store is this object, so it takes it and it stores it in that file. I'm telling you this, the reason is because this is the old auth library. The new auth library is not as nice. It forces you to actually manage the tokens yourself. So I'll show you this on the next slide, okay? So in this case, the older is better because it took care of this and I didn't have to write as much code. You'll see on the next slide that there's going to be more code because it doesn't, the new libraries don't do this. And I filed a bug. I said, you know, I'm complaining. Why are you making it harder for users? And it turns out that other libraries in different languages don't manage their credentials for users. So why are we doing it? So that's the reason why it changed to being slightly worse for Python developers, or is the same for everybody else. So anyway, the call to discovery.build is similar. So you still give the API name. In this case, it's Google Sheets. This version number, it's on version 4 now, the API. But instead of developer key equals API key, now I can take those credentials that I got, and I'm going to create a new HTTP client, because what I'm going to do is I'm going to encrypt all the transmission to the API because this is private data, right? So I'm going to authorize this HTTP client with these credentials so that I can now talk to this API and it will pass the access token every time it talks to the API and encrypts the data. So everything is much more secure, okay? So hopefully this is useful explaining it. Slowly running out of time, so I'm gonna have to go a little faster. But I just want to make sure you all understand this, and you can just watch this video because this video will explain exactly what I said. But I know the security is the harder part, so that's why I have a video you can watch over and over again until you finally understand it. Okay. So anyway, so the next slide is the longer. Sorry, I went through each one. So this is the new auth library in Python if you're doing your code in Python. So again, it's a little longer, right? I told you this, and you have to take care of the tokens files yourself. So storage.json is no longer being taken care of by the new auth libraries. You're doing it yourself. So I have to check if this file exists first. And if it does, then read it from the file and then save it. If I don't have the credentials or they're invalid, then check, do I have credentials and they expired and I have a refresh token, then refresh my access token. So I have to go through the OAuth flow. Otherwise, I do have to go through the OAuth flow. And so you can see everything is kind of basically the same. It's just a little bit more code, right? So I'm going to take my client ID and secret and my permission scopes. I'm going to build the flow, run the flow. And then when I get the credentials back, now I have to manually save it. So I basically open my token file to write with, and then I just write it out. Okay, and then discovery.build is identical. Okay, so you know, I just want you to notice that it's very similar to the old way of doing it, but just a little bit more code in Python. In other languages, you already have to do this anyway. So when you look at the same code for Node.js or Java or PHP, it's going to be similar. Okay, just different names mostly. But yeah, okay, great. All right, let's get going. So service accounts, little bit easier because there's more work being taken care of for you. Since this talk is not about how to use cloud APIs, which uses service accounts, I'm going to skip past this, but you can review it on your own. Service accounts are generally easier. Okay. Now, how do our APIs work? It's very basic, very request response workflow style. Okay. So what happens is you're running your app. Your app makes a request to a Google API. We check to make sure you have the right credentials, and if you do, the API services your request and then sends a response back to your app. It's very easy, very basic, very client server. Okay. So that's how almost all of our APIs work. There's some exceptions, but this is the majority of them. Okay, all right, so now let's finally talk about Workspace. I'm probably going to skip past a little bit of the code so we have more time for other things. I know I have about 10 minutes left or so. I don't think I can get through all of these in 10 minutes, but I'll try. Okay. All right, so first one, pretty easy, okay? Again, there's a video on this one, so I'm not going to go into this really in depth, but this is a very, very basic app that will list out the first 100 files and folders in your Google Drive. They'll just dump it on the command line, very easy. In fact, this app is only 4 lines long. It's just these bottom 4 lines. Everything else is the imports and the security that we just looked at, okay? And so here's your first example of a real scope. So if I'm just going to show somebody's files and folders in Drive, I don't really need to look at the data like in the file, right? I don't even need to do anything with the file. I'm not going to create a file. I'm not going to update a file. So I don't need to get access to the file contents. All I care about is the metadata, like the file name and the file type. So I only care about that. On top of that, I'm not going to do anything to the file metadata. I just want to look at it. So on top of that, I want to ask for just read-only permissions on the metadata for their Drive files. So how many of you, when you get that permission box, you ask yourself, why is this app asking for this permission, this permission, this permission, and this permission? Why is it asking for so much permissions? I don't like it, right? So now you're on the other side. Now you're the developer. So what we recommend is that you ask for the minimal permissions that you need for your app to work, right? Because I don't need to write to this person's Google Drive. Why do I need to ask for full Drive permission, right? Ask for something smaller or fewer so that my user is more comfortable installing my app because I'm not going to do anything bad to their data, right? So that's why I asked for just this scope, okay? So like I said, it looks like a URL, but on the screen, it's going to say, this app wants permission to read your metadata for your Google Drive files or something like that. Okay, and then everything else is the same. So assume the user clicks yes. Now I'm going to create a API endpoint to the Google Drive API version 3. I'm going to use those credentials that my user allowed me to have, and then I can say Google Drive, I have a collection of files methods. I'm going to use the one called list. I'm going to execute it. Once I execute that, by default, it's going to give me the first 100 files and folders in my drive. Now, maybe, that's the default. Maybe I only want 25. So somewhere in here, I'll say like max results equals 25. Or maybe I want 200. Then I can do max results equals 200, whatever. But if you take the default, it's 100. I did that because it keeps my code short. And then after it gets executed, I have some results in an object. And then I'm just going to do a getter on it. I'm going to get the files. And if nothing came back, then use an empty array so that my for loop doesn't fail on the next line. So if I have an empty array, it just doesn't print anything. But if I did get a bunch of files, then I'm going to print the name and the file type. Okay, pretty basic. So check out that video if you want to learn more. Again, this is using the older auth libraries. It's going to be a little longer to using the new auth libraries, right? But you already saw the code on the previous slide. So anyway, this is very similar to the quick start we have in Google Drive. All of our APIs have a quick start, which supposedly you can, in 5 minutes, start using this API. Generally, that's kind of optimistic, especially if you're new. But if you've already used one API before, then using another Workspace API is going to be pretty easy, right? So we're going to switch to like slides and Gmail and Sheets in a moment. I'm not going to tell you all these things about security, but you should already have an idea of how to do it, okay? So what can you do with the Drive API? I can back up file archives. Maybe I have like zip files or tarballs, and maybe I want to save those to Drive, but I want to uncompress them as I copy them to Drive so that I can actually see the file names of what's inside, right? So we have a code sample that does that. So it's a zip extractor. This one's in Node. It will take whatever zip files you have, and when you upload it to Drive, it'll actually expand and create a Google Drive folder called the name of the zip file, and then inside it uncompresses all the files for you. So that's one example. Another example is this one. I like to use this example. Like, you go on vacation, you take a lot of pictures, you went to Goa, you had a great time, you come back and like your Drive has uploaded everything to Google Photos, but I don't, my pictures look like this. I don't have a photo album. I have too many vacation pictures. I don't want to sort them. I'm lazy. So it looks like this on your hard drive or in the cloud, right? It's not very useful. So what you can do is you can use the Drive API, and you can use the Drive API to look at each file, look at the metadata, look at the timestamp, and look at the geolocation lat long. And you can actually build your own photo classifier. So you can create photo albums for like your holiday last winter, and then your spring break this year, or something like that. You can build your own photo albums using the Drive API. And then maybe you can put them into slide decks to share with your friends and family, or maybe you can build a video, upload it to YouTube using the YouTube API. Then you can send an email to your mother and father and say, hey, check out what I did on vacation. Well, maybe you don't want your mother and father to see what you did on vacation. But if you did want to do that, then you would use the Gmail API to send them a message saying, oh, your son or daughter has created an album, please take a look at it, or something like that. So you can use different APIs to build interesting apps. Okay, so that's that. Anyway, like I said, most APIs and products, whether it's in cloud or Workspace or YouTube or Maps, has Quickstarts. And so, like I said, it's the purpose is in all these different languages, you should be able to get started using this API in 5 minutes. Okay. All right. So Sheets API, like I said, I'm going to skip through these a little bit faster. Not spend too much time on the code, but like, why would you use a Sheets API? One reason is because maybe you have a database and you want to make it more visual, so you can read data out of the database and write it into a Google Sheet. Or maybe it's the other way around. Maybe your database is a spreadsheet, but you want to back it up to a relational database. So you can actually go the other way as well too. Okay, so there's lots of reasons to using the Sheets API. So here's an example of an API that reads from a toy order database. So I do a select star for all the toy orders, and it has all these column names. And what I'm going to do is I'm going to back up my database into a spreadsheet. So here, so I'm going to pretend you already know about the security code and how to create an endpoint to the API. So discovery.build sheets version 4. And then once I have the metadata for my spreadsheet, I can say, please create me the spreadsheet, execute it, and then give me the spreadsheet ID back, because I need the ID so I can write to it. So in the next line of code, I'm going to say, hey, I'm going to update my spreadsheet. I'm going to start with cell A1, and then I'm going to write all the rows in there, including the header names, the column names, because the database doesn't have that, but I want my spreadsheet to have it. So I add this as the first row in my all of my data. So that's why I added as row 0, and then all the other rows are my actual data, but I write it to a spreadsheet. Okay, and there's a video on this one as well too. Then Slides API, similar. You can use it to create, if you have like different customers and you want to have the same presentation, but you want to customize each slide deck. So maybe you want to interview at Tata Consulting when you're graduating. You create a presentation for all the companies you want to work for, and then maybe you want to generate one for Tata, one for Wipro, one for Capgemini. So you can have the same slide deck, but you can customize it for every customer. Okay, so lots of different uses for Slides API. I'm not going to go over the code because we run out of time, but there is videos for most of these, because like I said, I spent a lot of time on the Workspace team, so I made a lot of videos. So this is how you kind of replace text and images in a slide presentation. Same thing goes for Gmail. Maybe I want to count and only look at email threads that have a lot of messages, like more than 10 messages. So that's what this sample is for. There's a video on this one. So this is one word of warning is that email is a very sensitive topic. So some of these APIs require a lot of permissions, because we don't want you spamming people, or we don't want you accessing data that you shouldn't be accessing. So there are some restricted APIs that you have to, unfortunately, go through more security checks through Google in order to be able to publish your API, and Gmail and email APIs are definitely one of them. Okay. Google Calendar, creating events in people's Google Calendars, modifying them, or making recurring events. I made videos for those too. Mail merge is very popular. This uses the Drive API, the Sheets API, and the Docs API because you have a form letter that's in a Google Doc, and then maybe you want to read out all the data from a spreadsheet, from Google Sheets. So you need to use the Drive API to sort of manage all this stuff, and then you can auto-generate, read all that data out of the spreadsheet, and then use the Drive API to make copies of your web Google Doc template, and then just change all the variables inside. Remember, all the variables look like this: my name, my address, to name, to address. So you're going to have the same this is you on top, and then these are all the people you want to send the same letter to. Okay, Mail Merge, very popular app. Made a video on that, and the code sample you can download and use that as well too. Other Google APIs that you can use. Here's an example of a YouTube API to look for videos. Here's another one for finding locations on Google Maps by latitude, longitude. So here's like Google's headquarters. Here's a place in the Czech Republic. So yeah, so very flexible there. Very similar. So you can see, you make a client API client, and then you just use it basically. BigQuery, we're going to cover this more when we talk about the AI ML API. So I'm not going to go over this now. Same thing goes for Cloud Vision. Okay, so before we finish, I definitely want to talk about Appscript. So this will be kind of like the last section. So Appscript is Workspace Serverless tool. Remember I said I think you guys will be excited about this one because it's easier. So everything I just showed you is the harder way of doing things, and you have to host the code yourself. This one is where we host the code, and it's easier to use. So I think you're going to fall in love with this. Appscript, it is a secret because a lot of people haven't heard of it before. I know, shocking. But it's really not a secret. It's been out for 14 years now, so that's a long time. So it's not a secret. It's not even a well-kept secret. So it's basically JavaScript, but it's not like using APIs like I just showed you over the last 15, 20 minutes. It's more like built-in objects. And you don't have to write the security code that I just showed you and walked you through, okay? It is server-side, so it's kind of like Node, but it is not Node. You'll see. So here's spreadsheets. Can you code spreadsheets? Yes, if you know where to look. So you got to pull down tools and you see script editor. Okay, so that's your first hint. And so here's your hello world in Appscript. This is a one-line application. I just broke it up into 4 separate lines so you could read it easier, but it's a one-line application that will do the following. I want to talk to Google Sheets. I want to get the current sheet, the active sheet. I want to get cell A1, and then I want to write the value hello world into it. That's it. I save it. I run it. I get the OAuth box. As the user, you get the OAuth box. But look, I don't have any OAuth code here because it's auto-generated for you. So that's one of the best things about Appscript is that you don't have to worry about the auth code. You get the same, you get the same permission box. And when you click yes, when it's done, you'll see hello world in your spreadsheet. And it's exciting because you didn't type it yourself. You wrote code to do it, okay? So anyway, there's a video in this one too. But, hello world's not so useful. How about something more useful, like an address? So here's the address for Google's New York office. It's in cell A2. All right, what can you do with that? I'm going to explode my app from 1 line to 4 lines, and I'm going to touch multiple Google products to do something. I'm still going to talk to Google Sheets. I'm still going to get the active sheet. Now I'm going to get cell A2 because that's where the address is. But instead of setting the value, I'm going to get the value and store it in address. Then I could say, hey, Google Maps, can you make me a new map and put a pin or a marker on this address? And then line 4 is, hey, Gmail, can you email this map to my friend so that they can come join me at the Google New York office for lunch today? Okay, so this is a 4-line application that touches, this is an Appscript app. It touches Google Sheets, Google Maps, and Gmail. You're using 4 different Google products here. And this is kind of more useful, right? And I made a code lab for it so you can build this app line by line, and I explain what each line does, and you can also watch the video on it as well. So from here, you can probably do something more useful, like maybe I want to visit all 4 of my customers in New York. I want to plan my trip. Well, I can add, walking directions, public transit directions, biking directions, driving directions, whatever. Or maybe I have a monthly student club meeting or user group. And then I can use Appscript to, put the event in their Google calendars so that they know when the event is. Then I can use the Gmail API to send out reminders going, hey, don't forget to come to the user group meeting tomorrow night. Or the, I forgot what you guys do. Developer student groups have like hack days or something like that. Yeah, so you can send out reminders and put things in their calendars if you use Appscript, or the REST APIs if you want to do that. Okay, so that's more useful. All right, so Appscript powers add-ons as well, so you can actually add on to existing functionality. I don't know how many of you guys have noticed the progress bar down at the bottom, but Google Slides and PowerPoint don't have progress bars, or at least not that I know of. But my coworker wrote a Google Slides add-on in Appscript that automatically built this functionality. So he added on to the existing functionality. So the ability to do add-ons came out just a couple years ago. So give it a shot. You can also code other things like Data Studio and Google Ads. So lots of things you can do with Appscript. Okay, so inspiration. I think I will. Let me just talk about these now so that I can skip it in future slides, because then we're going to go over now, but then we're going to save the time in the other slide presentations where I show these same examples. Okay, so inspiration of what you can build with Google Cloud. So my coworker wrote this cool app that added custom intelligence to Gmail by analyzing workspace data using Cloud Platform. So what did he do? Or what is this? What did he do? So he's told me that he gets a lot of email, and Gmail does a really good job to filter out the spam. But even with the non-spam email, there's only a few messages he cares about. And he only cares about email that has attachments of pictures with birds. I know that sounds really weird, but just hold on for a second so you can understand what he's trying to do. And then you'll get a better idea of what he's trying to do. So what he did was he wrote an app that every time a new Gmail message comes to his inbox, it's going to notify our message queue service called Cloud PubSub, which I will cover in a future slide. All right, PubSub, if you ever use Apache Kafka for a school project, it's our message queue service. It's very similar to Apache Kafka. All right, so message queue, lots of messages go in, and then you have apps that need this data, then you just pull off of the queues one by one. Okay, so in this case, when Gmail has an inbox message, it sends PubSub notification. It will call a Google Cloud function, which I will talk about in the last presentation today. It's just a piece of code that is online that will execute. And what that will do is that will go and extract all the attachments from the Gmail message. It will call the Cloud Vision API. So the AI ML is coming up in the next talk. They'll call a Vision API, and if Vision API sees bird as one of the items in the image, then the Cloud function gets that result back, and then it's going to call the Gmail API to star that message, so that without running any code, the next time my friend logs into his Gmail, some of his email messages have stars because they have attachments that have pictures of birds in them. Okay? So yeah, it's not the world's most useful example, but it shows you how you can put together different Google technologies to build an interesting workflow. Okay, so the Gmail API can forward notify PubSub. PubSub can call a Cloud function, and the Cloud function can do anything and everything. So I'll talk about Cloud functions in the last talk. But if you combine everything together, he added custom intelligence to Gmail. You can read more about it if you click on the link to go to the blog post, or you can just go to the source code. This is in Node.js though. It is not in Python. So anyway, when you get this slide, you can just click on it and check out the GitHub repo. Okay. The last example is my example where I'm going from big data analysis to slide presentation by accessing GCP tools from Workspace. So in the next talk, I'm going to talk about AI ML. I'm going to talk a little bit about big data. So we have lots of big data. How do you make sense of it, right? One of the tools that we have to help you make sense of it is called BigQuery. So I'll talk about it next. But you can do all the hard work by issuing, perfecting your SQL queries so that you can do deep analysis on a large chunk of data, and then you'll get results back. And you see that there's a download a CSV link here. So once you're done, you can look at it here. You can take a screenshot, or you can download a CSV. Pretty useful for you as a data analyst or a future data scientist. But when you become an employee, you cannot just give a CSV to your manager or your boss or your CEO. They're not going to look at a CSV file, right? So in this case, you only finished 80% of the job. It's like the stairs here. You can use them, but it is not pretty to look at. It is not beautiful to look at. So please try, and even though you're doing the 80% of the job, finish the last 20% by making your data more visual, more visually appealing, makes it look better. Okay, what's better looking than a CSV file? Because you have to show your boss, right? Better than a CSV file. Bosses understand spreadsheets, right? Right? And then if you're using the Sheets API, you can tell the Sheets API, after you import this data from your code, you can tell the Sheets API to go make a chart automatically, dynamically with code. And then if you're going to present to your manager anyway, you got to give your boss something useful. You're probably going to make a presentation. Why don't you take the data, put it into a slide, take the chart that you just made, put it into a slide. Why don't you just build the entire slide deck, right? Because if you're already going to do the hard work, you might as well do the easy part where you're automating building a slide deck, because you have to present to your boss anyway, right? So do that last 20%. Make your data and your results more visually appealing. Okay, so this is an Appscript app. I'm sitting at the console. I click on the run button that calls BigQuery. The results come back. I put it into a sheet. I tell the sheet to make a chart. Then I create a brand new Google slide deck. I import the data and the chart into it. And now I've gone from big data analysis all the way to boss ready slide presentation. And if you look at the source code, all of this, if you remove all the blank lines in the comments, this whole thing is less than 100 lines of JavaScript. Less than 100 lines to do this, okay? So it's not overly difficult, okay? So I made a code lab so you can build this app line by line. I also made a video. You can take a look at it. You can also go take a look at the source code. And I also presented this a couple years ago at the Cloud Next conference, which is our big cloud conference. Okay. All right. So now that I did that, then the other two presentations will be easier. All right. So wrap up. Workspace. It's not just a set of apps. You can code them too. You can automate things. It's very useful. You can take advantage of the data that lives in your workspace if you're a company, right? If you're a company and you have your own company Google Drive, your own company Gmail, you have a lot of data that you can analyze. So the question is, where do you want to run your code? If you want to run it in your environment, then you can use our APIs that I told you earlier. If you want to run your code in our environment, Appscript, you code it in the editor, in the browser. You can also do it on the command line, and then you can also upload it. We have a command line tool for you. And you can do interesting things if you use different Google APIs combined. So that's why I'm into that. Okay. All right. So a lot of links for you, a lot of code samples for cloud. I probably have some workspace links somewhere floating around as well too. Yeah, not too much to look at here. Here's the more specific stuff for workspace. This is more important. So take a look at those. I have some of the videos that I had inside this presentation. They're all summarized here. And then Code Labs, again, are self-paced hands-on tutorials if you want to learn how to use any of these, including Clasp. That's the command line tool for Appscript. So if you want to develop locally, you want to automatically upload to the cloud instead of editing in a browser, use the Clasp tool for that. So you can try these all out. And that's pretty much it. All the other Google APIs, I'll talk about GCP next. Firebase, maybe not as much, but that's our mobile development platform for Android and iOS. If you have a lot of data and you want to build a beautiful dashboard to look at, nice visualization, look at Data Studio. If you want to build voice-driven apps, look at Actions on Google, where you can build apps for the Google Assistant, or so you'll be using Dialogflow to do that. YouTube has APIs, you already figured that out. Maps has APIs, you already know that. Flutter is sort of like the latest hotness. I'm sure you guys have already talked about it. But you can write a Android app, an iOS app, and a web app all with one code base, so you don't have to write separate versions for each. So that's Flutter. And then that's it for this particular talk. So I'm going to, so here are the slides for the longer version of this presentation, but I will also give the organizers of the hackathon the actual PDFs for this talk. So you can get both if you want. This is a long video that goes much more in depth. It's one of my Cloud Next talks that really gives sort of like more detail to what I talked about today. And if you're more interested in the progress bars down at the bottom, there's a link to that. My daughter says hello. She likes to draw these anime characters. And then here's a link to this Google Doc again. So I'm going to temporarily hand it back over to the conference organizers to organize maybe a 5 or 10 minute break. And then I'll come back with the next presentation, which is going to be the AI machine learning one. Okay, so I'll hand it back to the organizers now.
Yeah, so thank you, sir, for the amazing first session that we have experienced, and we gained a lot of knowledge and about it. So now it's a notice for all the participants present over here. As sir said, there would be a 10 to 15 minutes break for the next session to be started. You can probably get a drink and have your restroom attendance and all, and just enjoy the break, and then come up with a newer mindset and carry on with a new topic. So thank you for attending.
Okay, I'll see you guys in maybe about 14 minutes, 13, 14 minutes.
Yeah.
Ending.
Yeah, so it's been 15 minutes for the break now, and I hope that everyone has been back to the setup for the next session. So it would be upon the easier part to machine learning. So I will hand over sir to just start the session for the second thing. And the setup is also perfect, sir. The screen and your imaginary laser also is visible right now.
Okay, great. Thanks, Nora. All right, everyone, welcome back. Same short link to the Google Doc. Originally, this talk is called Easy Path to Machine Learning, but you'll discover there's no such thing as an easy path to machine learning. What I can do is I can give you an easier path to machine learning. So I think that's the best I can do, because machine learning is a little bit more complex and it requires a little bit, it has a more of a learning curve in order to really understand it. So this talk is for people who are considering this, but wondering how challenging it is and how can I get into it easier? What is the better on-ramp? What is an easier on-ramp? How do I get started without being overwhelmed? Because if you all of a sudden just want to do TensorFlow, it's not that easy, right? So I'm going to try and show a better, a more gradual growth into the field of machine learning. So I think that will be more helpful for everyone. So anyway, it's me. I don't need to introduce myself anymore. We can go past that. This talk is broken up into 6 parts. And the main reason for this talk is because big data is everywhere. You know, before Facebook, before Twitter, we didn't have that much data, so we did not need to have machine learning and AI, right? AI has been around since 1960s. It's been around for more than 60 years, but we never really needed it until recently. When everybody has Facebook posts and Twitter and Instagram, now there's way too much data. And so we have to have machine learning to help us understand or to get information out of all of that data. So now AI and ML is a big thing, and data science is an industry and a profession now because there's so much data. But it does require a certain level of maths and statistics. And so this is what gives AI and ML a learning curve. So if you're not good with mathematics, it's difficult. But I don't think you guys will have a problem, just because, as engineers and software developers, we have to have some minimal level of math and statistics. But maybe we're not PhD, right? So the way to make it easier is if you have APIs that are backed by machine learning. It helps make it easier to get in, because if you as a programmer can call APIs, now you can use machine learning without having to get into all the science and the theory behind it. You can just use it to your advantage. So this is giving you a high-level introduction to using Google APIs, but more specifically our AI and ML APIs in general. So between the introduction, which is what is machine learning, that has nothing to do with Google, it's just what is machine learning in general. I will introduce, Google Cloud. It's probably going to be a short version because you already learned about Google Cloud in the last talk, and you already learned about Google APIs, so we don't have to spend much time there either. But we will spend a lot of time on our cloud machine learning APIs, and also some other related cloud tools in addition to the APIs, or maybe other related APIs. Okay. All right, so let's get started. One thing I do have to tell you is that I am not a data scientist. I'm a developer like many of you. So your journey was my journey. However, because I know how to call APIs, that gives me the power of machine learning, even if I don't know how to do machine learning very well. Okay, so what is machine learning? AI, ML, and basically making computers smarter, so to help us understand more and get more insights out of data. So that's really the purpose of machine learning. Okay, so quick question. How many of you know the difference between a puppy and a muffin? Okay. Now, you as a human can tell which one is the puppy and which one is the muffin or the cupcake or whatever. Language is very different, right? It's very challenging. You can tell because you're a human. Throughout most of your life, you have been taught to recognize a muffin and, well, maybe not a muffin. I don't remember seeing too many muffins when I went to India, but it's a baked good, okay? Maybe a puri or something, right? Or naan, okay? So you know how to recognize that, and a dog, right? Because you've seen millions of dogs and billions of naan, okay? So you can tell. But can you teach a computer program to recognize the difference between a dog and a muffin or a puri or whatever, right? So that's one challenge. Maybe I want to ask you the question, what is a coelacanth? Is that a coelacanth? I don't know. Maybe it's a rock band, coelacanth, right? Nobody knows because it's a word that you're not used to. Now, we're used to dog, we're used to muffin maybe, but not coelacanth. What's coelacanth? Coelacanth is actually this ugly fish that nobody should eat, because if you catch it, you don't want to eat it because it's terrible. It makes you sick. So don't eat this fish, okay? But if I just said coelacanth, you didn't know what it was because you didn't get trained over many years like you did for a dog or a muffin, right? So now we have the challenge. How do you teach a computer program how to do it too? Okay. So back to the original question, can you tell the difference between a puppy and a muffin? I'm going to ask you the same question again. Can you tell the difference between a puppy and a muffin? What did I just do to you? I just made this problem much more difficult than when it was this picture, right? It's the same question, but now it's more challenging. So now if you think, how hard is it for me to write a computer program so it can recognize the difference between this dog and this muffin here? And then how good of a computer program do you have so that you can use this data set on it? This data set is much more challenging. In fact, it's harder for us as a human to recognize which one's a dog, which one's a muffin. Pretty sure we can all figure it out. Because your original hypothesis, maybe it has eyes, maybe it has a nose, maybe it has a mouth, maybe it has ears, that works here, and for a dog, and maybe a muffin is a cake with a colorful paper around it, right? But that algorithm fails on this data, right? So it's much more challenging. If you like these pictures, there's a link down here you can go to see more pictures like this. Okay, so this is, again, same question, but a much more challenging answer. And guess what? It's even harder to get a computer program to be able to tell the difference between a puppy and a muffin here. Okay, so that's the power of machine learning. It's not just rules. I gave rules like it has eyes, a nose, a mouth, ears, colorful paper, it's a mound, looks like a mountain, right? Those rules don't work on that other data set. So machine learning is basically, yes, we have to have some rules, but now we have to have some experience, like, I know this is a muffin, I know this is a dog, I know this is a muffin, I know this is a dog. All right, so that's what's called training. If you can build this thing called a model, and you can train this model to recognize between a dog, a puppy, and a muffin, then you'll have a better chance. Okay, so that's what we're going to be doing. It's rules and experience. Okay, so you give your machine learning model or neural network, lots of pictures of cats, a lot of pictures of dogs, and maybe a lot of pictures of muffins. And then you label it, meaning that this is the picture of a cat, this is a picture of a muffin, this is a picture of a dog. And you give it thousands and thousands and millions and millions and millions and millions. And so it has a clue to figure out, oh, it has this characteristic. 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 It's got to be a cat or a dog or a muffin. Okay, that's kind of how it works. So that's the training. Can you build up an adequate training set so that your model is accurate? Once you do that and you have a good model and you validate it, then what you can do is you can test it by sending it new data that it's never seen before. And based on the training that you gave it, is that training good enough to tell if this is a cat or a dog or a muffin? So it's going to use the same layers to not just turn the picture sideways, right? And you're just going to like trigger these different neurons until it gets a better clue, all the way until it's definitely either a cat or a dog. Okay, so that's how it works. All right, you've used machine learning before. Maybe you didn't know it. Maybe you asked the Google app on your phone, on your watch, or a Google Home device. Maybe you said, okay, Google, please tell me the movies that I can go watch or something, right? A lot of mobile searches are done by voice now. We don't type it anymore because you're on the go. You're mobile. You're not going to always be typing. It's just easier just to talk it into your phone, right? So that uses machine learning. Google Translate, you have a lot of languages in India. And if you're traveling from one part of the country to another, I mean, I know people can generally speak English and maybe Hindi, but that's not always the case, right? Translate used to be more of a rules-based system, but it wasn't so good. But then we turned it into a neural network, and Google Translate has gotten much better. If you notice that this came out in 2016, so that's the year that we updated our model to actually using machine learning. So that time, 5-6 years ago, that was when Google Translate got really good, because now instead of just looking for rules like this is the noun, this is the verb, this is the subject, this is the action, now we see millions of examples of using this language and using these words put together so they're similar, they're related to each other, and now we can do better models to figure out what it is, okay? And then same goes, I don't know if you have an Android phone, but did you notice that if you go to Google Photos, did you notice that there's a search bar? How does it know what you're searching for? How does it know what's in your photos? Did you give it training data? Did you say this is a dog, this is a temple, this is this, the city of Mumbai or Chennai? Did you do that? No, you didn't. Okay, so Google Photos has built-in models to help recognize things so that you can use the search bar to actually look for photos of something. Okay. And many Google products use some sort of machine learning. Okay. And the amount, it's been growing. Notice that this slide only goes up to 2019. I don't even, for last 3 years, it probably is off the charts now. Probably every single product we have uses machine learning. But it started around the time that big data became really big. I think, I think Facebook maybe started like in 2005, 6, 7. And then Twitter came around, and then Instagram came around, and then all of a sudden just the amount of data that's generated has gone crazy. So the number of directories and folders that have machine learning models in Google's source code has grown at the same amount, right? So that's why we're committed to it, because we believe in it, because it's helping our business as well too. Okay, and it's not just our business. There's other companies around the world, such as this one, Global Fishing Watch. So in order to preserve the planet, we can only catch the appropriate number of fish in your geographic region. You don't want to overfish, because then the fish can't reproduce and you won't have any more fish, and then that's not going to be good, right? So the Global Fishing Watch tracks how much fishing is going on by which kind of, it can recognize a Navy military boat. It can recognize a cargo freight boat. It can also recognize a fishing boat. So it knows what boats look like. Okay. So 1 billion people depend on seafood. 85% you're either at the level of fishing, or you're overfishing, or you're just recovering. So it's very sensitive. 20% of all seafood is caught illegally, undocumented, unregistered. And so monitoring this from analysts, humans doing it, is not scalable. So now Global Fishing Watch, the whole purpose of it is to use machine learning classifiers that can tell the kind of ship, I just mentioned that, not just the type of boat, but also the size, and also what kind of gear is on that boat. Is this really a fishing vessel or not? And also movement of these vessels. Where are these boats going? So we can better track this information. So this is a positive for the planet Earth. We want to make sure we have enough fish in the ocean for everybody for many years. Okay, same thing goes for food quality. Maybe some of this food, is intended, cheese or whatever this is to make baby food, and maybe there's some mold, or the food is a spoiling. I want to recognize it and I want to pull it out. Or maybe I have good cucumbers, big cucumbers versus small cucumbers. I want to make sure they're sorted in the right boxes. Okay, so these are two different stories of using machine learning to help with the world's food supply. Okay, so anyway, so those are just some examples. So a lot of people think machine learning is a bunch of data, very, very difficult math, and you have magical results. I mean, it seems that way, right? But in reality, it's collecting the data, organizing the data. Then you have to create a model and basically train it with a lot of data so that it becomes accurate. And once that's done, now you have a really good model, and then you can give it new data and it can make accurate predictions. Okay. So the keys to having successful machine learning are to have a lot of training data, a lot of good models, and basically lots of compute power. Okay. All right. So traditional programming is you give a bunch of rules like code, and then you give it data, and then you get some output. Okay. Not quite the way it works with machine learning, because you actually have to give it the answers. Like, this is a cat, this is a dog, this is a muffin, and then yes, no. Is it a cat? Is it a dog? Is it a muffin? And then what you do is you build a machine learning model, and really you get output a set of rules. So it's a little bit different from traditional programming. Okay, so once you have this whole setup, okay, that is the model, and that part is called the training phase. Once you're done, you have enough training data, you validated the model with validation data, then you can do the inference or the predictive phase, and that's where you give it new data, and depending on how good your model is, that determines how good your predictions are. That this is a cat, this is a dog, this is a muffin. Is your model good enough to tell the difference between them? Okay, so training and inference. So I'm teaching you some of the words like model and inference and predictive. I'm teaching you some of the words so that as you get into machine learning, it'll be easier, so that because you already know what they are. Basically, now you're ready for the theory. Now you're ready for the more challenging math. Okay. all right, introduction to Google Cloud. Google Cloud, I don't think we had this slide on the last one, but our Google Cloud is basically our data structures, data centers look like this. Inside these data centers on all these machines are running Google Search, YouTube, Gmail, and of course with Google Cloud, your app is going to be here. We don't have special data centers just for users. Your code is going to run on the same machines as YouTube, Search, and Gmail. So whatever we do in our data centers to make it faster, to make it more memory efficient, to use less power, you get that for free if you are a customer of Google Cloud. So we are probably the most green of all the different clouds. We care about the environment. If you want to learn more about our data centers, go to the link down at the corner down here. Okay. So you already know what Google Cloud is. We have two products, Cloud Platform, Workspace. We spent time on Workspace in the first talk, but now we're going to look at Cloud Platform. Cloud Platform provides lots of different things in higher education for faculty, researchers, and students. Well, we give you virtual machines, GPUs, different types of storage, networking, machine learning models, which is what this talk is about, container hosting. We also provide infrastructure for you to do machine learning building of models and deploying of it. And then the third talk today, we'll talk about serverless. We also provide additional, if your school, if your university has a data center, you don't have to just throw it all away. You can use your school's data center, but then you can add additional capacity, or maybe if there's a typhoon and it took out your data center or parts of it, then you can actually use cloud to provide emergency computer storage capacity. And we also make productivity tools like Workspace for students and professionals that you already use. And also to help people who are students or faculty, we have education grants. So I'll talk more about those. So this is how you can use Google Cloud for free without paying or without giving us your credit cards. So talk about that. So this talk is about our machine learning building block APIs. So these are our APIs that I'm going to focus on tonight. So vision, video intelligence, to-speech APIs, natural language, and translation. So you can gain a lot of insights using our pre-trained machine learning model. So what do we mean here? So you already saw that in order to be able to make good predictions, we have to have a lot of data. We have to train a good model, and then we can use that model once it's validated as good to make new predictions, cat, dog, or muffin. The cool thing about these APIs is that they are already pre-trained. In other words, Google scientists have trained these models for you, and they already put them online. So all you do is you call them and you give them the data, and then we give you the predictions that come out of it. So that's why it's easier, because you don't have to go through the training phase. You don't have to do the math required to build and train your models. These are already pre-trained. You just call the API, give it new data, and then get the results back. You don't have to have any knowledge of machine learning other than you're using machine learning. That's the only thing you need to know. And basically, if you can call an API, you can use AI machine learning. Okay, this link is no longer there because they merged all of the building block APIs into our larger AI system called Vertex. So if you go to this link, it'll just take you to Vertex, which isn't very good. So I made it so that when you click on this, it goes back to the old web page that used to be there to show you more about this. So don't type this in, just click on it, and it takes you to the original one that we had before. Okay. All right, so Google offers a lot of different AI and ML products and features and libraries. So basically, this tells you a little bit about where they sit on the spectrum. So the spectrum is, I'm a pure app developer. I don't know anything about machine learning, all the way to I'm an advanced data scientist and I know everything about machine learning. And so we have products for everybody, depending on what your level is. So if you're new to machine learning, you use our building block APIs. Okay, these are pre-built, pre-trained models that are already there. If you're a little bit of a data scientist and you're starting to get into it and you like these models, but they're not quite right for you, we recommend that you use the AutoML versions of these APIs. And so I'll talk about that later on in this talk. And if you already know what you're doing and you want to build and train models, but you don't want to buy your own computer equipment because it's too expensive, or your school doesn't provide enough hardware for you to use to build and train models because they're computationally intensive, then you can use AI platform, which is now called Vertex AI. That's our big overall AI platform. And so you can build your own models, you can train them, And then you can also serve them. You can basically make it available to the public, and you can say, hey, everybody can upload data and get predictions on this. So you're probably going to be using TensorFlow or Keras or PyTorch or something like that. All the way to the right-hand side where you're using these libraries on your own. You have your own hardware. You don't need Google Cloud at all. Okay, so we have something for everybody. All right, so Google APIs. What are they? How to use them? I already mentioned this before. We have APIs because you can't wait for Google to write every app for you to use in your whole life, right? And then so we have APIs so that you can use it for your next web app or your next mobile app. And then you already learned what the difference between auth-in and auth-z are. You already know how to use our APIs. Basically, I don't think we had this slide last time, but this gives you the steps that I outlined in the last talk, which is you go to the console, you log into your Google or Gmail account, you create a Google Cloud project. So every project is an application. You go to the API manager or the dev console and you turn on whatever APIs you want to use. Maybe they have billing, so you may have to submit a credit card or a free trial, or if you have student credits, you can do that there. You go and download whatever client libraries for those APIs to use those APIs. You create and download your credentials in the Cloud Console. You write your code, you run your code. And if you're asking for users, if you're trying to access users' data, they have to give you permission. They have to authorize your app, right? We've already done this, okay? So for costs, I already mentioned that Google Cloud Platform is pay per use. So every time you use it, you trigger some billing. A little bit more of that in a moment. So it's pay per use. Workspace is paid by subscription. I already told you that. Workspace is either paid for by your company, or it's free at school, or you have a Gmail account, in which case it's free. For Cloud Platform, because it's pay per use, that means money has to come in. I have to get paid. I want to work and support my family, so I need some money. So please support me. There's a thing called a free trial. It is $300 US for 90 days, 1 quarter, 3 months. But you need your credit card. So we tell students, don't do it. Do not do this as a student. Because if you use up the 300 and you accidentally convert it to a real account, it's going to bill your credit card, thousands of US dollars, and that's not going to be fun, right? So don't do the free trial. Never do the free trial until you have graduated from school, you have a paycheck, and you have 90 days worth of playing around with cloud. That's the first time you should use it. You should never use the free trial as a student, ever. Okay, it's just bad. One thing you should know is that there is an always free tier in Cloud Platform. I shouldn't say most, I should say many cloud products have a free tier. What that is free usage, either for a day or a month. And you have to go over that amount. You have to use more than the free tier in order to get billing, to get billed, to get charged money. So if you use our stuff and you stay under the limit, so for example, BigQuery has a free quota of 1 terabyte of data analyzed. If you never analyze more than 1 terabyte of data in 1 month, you will never get charged, even if we have your credit card. There is no monthly fee for using Cloud Platform. It's only paying per use. And if a certain amount of usage is free, then you can use all the way up to that amount before we bill you. Okay, so keep that in mind. And there's a link more on both the free trial as well as the always free tier at the link here. Okay, so you can learn about it. So you don't even get billed if you use always free. So most of the time you can use always free. A lot of people use always free to run their websites and they never have to pay Google. Okay, they just have so few users. You only have 10 users and they don't really access your website very much. So why should you pay if they're not using it much, right? Google's not good at charging money for things anyway. You have to be a really big website to use up enough resources to pay money, okay? All right, all right, Cloud Console, you already know how to do this. I'm not gonna go over this. Dev Console, APIs, how they work, you already know that. Wow, okay, Cloud ML APIs, easier path to machine learning by just calling APIs. So first one is Cloud Vision. Cloud Vision lets developers extract metadata and understand the contents of an image, identify and detect objects, those are called labels, to able to read text or OCR, which is optical character recognition. All right, so that's just basically reading text and then turning it into a string so that your app can process it. It can recognize famous landmarks like the Taj Mahal, I guess is the most famous in India, but you know, in Aurangabad, there's also the Ajanta and the Ellora caves. All right, and there's also, you know, fancy temples in Khajuraho, I think. So landmarks, famous landmarks, okay. It can also recognize well-known product or company logos, like the Google logo. It knows how to recognize facial features. It cannot do facial recognition. It can't recognize a person, but it can tell if somebody's happy or sad or angry. It also knows how to recognize well-known products. And also, you know, for young children, you don't want them to see explicit content. So there's a model for that as well too. So all of this is available in the Cloud Vision API. Okay, and so there's a homepage for the Cloud Vision APIs down here, so you can try it out. I think there's a free, you know, you upload an image and then we tell you what's in it or something like that. It's kind of fun. All right. So here's an example of how to use it. So Cloud Vision API has its own client library. So this is going to be slightly different style than the earlier stuff I showed you with Workspace. You can use the Workspace style, the lower level client libraries, you know, discovery.build, vision, API version 1. You can do that, but then you have to write the auth code. Notice how much auth code I have in this higher level client library. I have no auth code. All right. In fact, all of the auth is done in this one line right here. Okay. So higher level client libraries for you. Okay. So I import the Vision API client library. I have an image I want to analyze. It's sitting in Google Drive or Google Cloud Storage. That's why it's GS. It could be HTTP, right? You know, it recognizes both. So first thing, you know, discovery.build, right? I create an API endpoint, so, or API client. So here's the client. I'm going to do an image. I'm using the image annotation, labeling. Okay, so I have an image object, and then I'm going to pass that the URI, the location of this object, this image. Then I'm going to say, hey, detect objects and give me all the labels of objects that you see in this image. And in my response, I'm going to see a list of labels of objects that the API sees, as well as a confidence score that this is accurate. And then draw an empty line, 30 equal signs as a line, and then just print out all the labels. And then the confidence score is a percentage. Okay, so for example, given this image, okay, you can kind of tell it's something in China, it's Shanghai. All right, so this is the image. It's a street view. It's a shop. It's a person on a bicycle. People walking with an umbrella. Other humans as well too, moving around. So when I run this code, labels, objects that it sees, and the confidence score. People, it's 95% sure there's people in this image. 89% sure that it's a street view. 89% there's transportation on this page, or 85%. 89% of what type of transportation. 84, more than almost 85% that there's at least one vehicle in this picture, that this is a snapshot moment in time, that this is an urban area. I don't know how I can tell that, because this could be a village. Well, maybe it's a buildings. There's infrastructure here, a road, buildings. There's the road as well. And then there's pedestrian people walking in the streets. Okay, so this is part of the Vision code lab that I help update in Python for using Cloud Vision. So this is an idea of how to use it. The next one I don't have a sample for, but it's very similar to Vision, so that's why I put them next to each other. This is the Cloud Video Intelligence API, and this one works very similar way. Instead of one still image, it searches all the frames of a video so that you can actually search or make a video searchable. You can make it discoverable. Somebody is riding in a tuk-tuk here. Somebody is riding on their bicycle. Somebody's in a car. You can identify parts of videos where this is happening. It could track objects that are moving across frames. It could tell when the camera angle changes, and it can also read text. Okay, so video intelligence, very similar to vision, but a little bit more complicated because instead of uploading an image, you upload a video and it analyzes the video. And there's a homepage for it. So if you want to learn more or try it out, I think there's a demo on that one too. All right, the next one is the natural language API. And this basically reveals structure and meaning of text, as well as performing sentiment analysis, meaning is this text positive or negative? It can also classify content like this is from a financial document, this is business news, this is a social post or whatever. Entity extraction, so if you have the word Google or Ahmedabad or Delhi or Taj Mahal, it could recognize entities. And then it can also do syntactic structure analysis, like this is the noun, this is the verb. It can also support different languages as well. I don't think it supports any kind of Sanskrit quite yet. I think right now it's just European languages first. But anyway, so natural language. Here's a demonstration of it. So I'm going to import the natural language client library. I have some text here I want to analyze. I'm going to use sentiment analysis. So you guys tell me, if you read this, tell me if you think this is positive or negative. Okay, so just look it over really quickly and get an idea in your head, is this positive or negative? And then we'll see if you're right on the next slide. Like all other APIs, you got to create some kind of API client. I'm going to pass in this document. So that's this text here. That's my document. It's in plain text. And I'm printing out the text so that I can see that this is what it's being analyzed. I'm going to analyze the sentiment of this document. Please give me the sentiment back when you're done. I'm going to print out the sentiment as well as how strong that sentiment is. And then I'm going to classify this content. All right, so I'm going to request the API to classify this and then give me the categories that this text should be part of. And then for every category, display the category and then the confidence score that it belongs in that category. All right, so what do you all think? Positive, negative, right? I think everybody thinks it's positive. Why? Because this word love is there. This changes everything, right? Without the word love, you don't really know. It's kind of neutral, right? So let's see if we're right. The answer is correct. So here's the text. Here's the score. So if it is greater than 0, then it's positive sentiment. If it is less than 0, then it's negative sentiment. And how strong is it? It is pretty strong, okay? 0.5 is pretty strong, but not overly strong. Why? The reason is because love is, is a very specific word, but there's only one word. So the score is low because it only found one example to show if this is positive or negative. If I have other positive words in this text, the score will be higher, but it's not that high because there's only one instance of a positive word. But is love a strong or a weak word? It is strong, right? If this word was like instead of love, the magnitude would be lower because like is less strong than love. So that's why the score is low, but the magnitude is high, because love, there's only one instance of a positive word, which is love, but love is very strong. So that's the score and the magnitude. As far as categories go, this text looks like it's related to internet and telecom, 76%, computers and electronics related, 64%, and 56% chance this is news. Okay, so that's how you use, that's one example of how to use the natural language API. It's not these are only 2 use cases. It does other things, right? It does lots of other things that I don't have here demonstrated. Okay, all right, speech to text, text to speech. So one will convert spoken speech into text strings that your app can process. So that's the speech API or speech to text. And then the other way around, if you have strings, but you want to put a voice behind it, that's the text to speech API. Here's one example. So I'm using the same text that I had before. And what it does is basically this will just, this is an example of using the old client libraries because it uses discovery.build. So that's how you tell if it's lower level or higher level client libraries. Okay, discovery.build is always the lower level one. So this is a demo of how to use that. And because I'm just passing in an audio file, it's not somebody's data sitting in Drive or cloud storage or a database. So I only need an API key. And I wanted to recognize the content in this audio file, which I pass it, and then just read it to me. Okay, I don't have a demo of this one, but this is just demo code. Okay, that's what I did. I took this example and I recorded it on my voice. I said it out loud, and then I had this API read it out loud. So it doesn't do punctuation very well. There's no periods or commas, but it's able to understand the words. So it's 92% confident that these are the words that I spoke on the audio file. Okay, so that's the speech to text. Cloud Translation API, pretty popular. This is basically the API for Google Translate. Okay, it has a free tier. You can do a certain amount of translations for free every month, but we do charge money for it if you go over a certain amount. Okay, so here's an example. I try to translate "Hello World" into Gujarati. I don't know how well this turned out because I can't read this, but I'm sure many of you know how to read this, and hopefully it's very close to "Hello World." I don't think it's hello or greetings because it doesn't look like namaste to me. It's something else. But anyway, this whole point is to demonstrate. Oh, by the way, this is in JavaScript and Node. So in case people are tired of Python, change it up a little bit. Okay, so you can see it's kind of similar to Python. Instead of import google.cloud translate, it's require. And then I'm still creating an API client. Here's my target text. Here's my target language. And here's where I call the API to translate the text from English into Gujarati. And I just log it into my console, and it outputs this. So I just cut and paste it. Hopefully that's right. Gives you an idea of how to use the translation API using Node.js. Okay. Now, I mentioned earlier, what if these APIs are good, but not good enough for my use case? Maybe I'm in graduate school and I'm using the Cloud Vision API, but instead of recognizing a cat, a dog, a muffin, or a plane, or a ball, or a book, maybe I'm taking a medical imaging class where now I have X-ray, CAT scan, CT, MRIs, medical images. Our Cloud Vision API model was not trained to recognize medical images. Maybe it's pictures of flowers. Maybe it's construction blueprints to build a building for architects. The Cloud Vision API is not trained with that data, so it will not do well. It may tell you it's a flower, but it doesn't tell you what kind of flower. Okay, so if you are a biology student, botany student, and you wanted to recognize specific species of flowers, you're going to have to do something else, right? You cannot use the Cloud Vision API. In this case, we recommend that you use AutoML, which is basically the same APIs that I just talked about, but customized to allow you to continue to train them using your data, using those medical images, using those images of all these flower species, using these construction blueprints, so you can customize the Cloud Vision API to your data set. So now this is the AutoML Vision API, not just the normal Cloud API. So you can see the icons are similar, but a little different. Okay, it has the AutoML enclosure. Okay, so this is used by a lot of students in hackathons because it's really powerful. Or, students are already using Translate, Vision, natural language, and video intelligence on their own for hackathon projects. But if for some reason your data set is very, very different and you want to make a custom version of those APIs, that's what AutoML is for. And I've seen student projects using AutoML. It's incredible what you can do. And again, you do not have to have much, machine learning expertise, just a little bit. You have to know your training, right? You have to know you're working with building a model, altering the model to fit your data set. But as long as you know those basic things, you can use this even if you are not an AI machine learning student. If that's not your major, that's okay. All right. Now this last one is a little bit different because there is no standard API for this. You can tell it looks a little bit like a spreadsheet, and that's what it is. It's basically AutoML for structured data, like a spreadsheet or a relational database. We don't have an API for that. But what you can do is you can train a machine learning model using AutoML on top of structured data, such as, let's say you had a spreadsheet of what kind of jobs are in Hyderabad versus Ahmedabad versus Mumbai versus Chennai versus Bengal. Let's see. What's another big city in India? Um, um, Madras. No, that's Chennai. Sorry. Anyway, so let's say you have different jobs in those cities. Then you have like, what is the salary? Like how many lakhs or rupees that you get paid every month or something. And then you put all this in a big giant spreadsheet. Now you want to know, where's the best city I should move to with my college major so I can make the most money. You can kind of do that using AutoML tables. If you had such a spreadsheet, I'll assume you can kind of figure that out if the government releases some of this information. Okay, so that's one example of how you would use AutoML tables. There is no, machine learning model for just the data by itself because we don't know what kind of data it is, right? But you can build an AutoML table for structured data. So anyway, so that's AutoML. So the way you use it is you prep your training data, you create your data set, you import all the items, your training items into the data set, then you use that data set to create and train your model. Then you evaluate or validate the model to make sure it's accurate. And then once you have a good model, then you make predictions on it. So this is almost like what you have to do in real life, even if you weren't using AutoML. If you wanted to train your own models anyway, you still have to do all that. But AutoML helps you because you're already starting with something that's already been trained, and now you're just making the training more specific. Okay, so that's why AutoML is really cool. Okay, so again, Vertex AI is our whole platform. It's like everything. It's these building block APIs plus the infrastructure stuff. If you don't have enough hardware, we provide the hardware for you. You just rent these machines to train your models with. It could be expensive, right? And then you can deploy these models and make predictions on them. And you can use all these well-known libraries once you get into machine learning, okay? So just look at it all. It's just one giant platform. Some other cloud tools that may help you out with this. BigQuery is our data warehousing tool. I kind of showed you a little demo of that in the sort of like the demo apps there. But basically, you can take multiple terabytes of data and just issue simple SQL queries on it. You can't do this with MySQL or Postgres or SQL Server because you cannot put that much data in it. But BigQuery, you just stick all your data in cloud storage, and then you tell BigQuery, hey, I want to issue SQL on this data that's sitting in cloud storage, and it knows how to do it. Okay, so here's an example. Shakespeare has a lot of writing. Okay, it's not multiple terabytes because he only had plain text. So it is still, I think, like 36 megabytes. But this job that I want to do on it is still pretty challenging. You don't want to do it by hand as a human, even though there's only like 36 megabytes of plain text data. So the query is to find what are the most common words. So if you were to take all of Shakespeare's writing, dump all the words into a giant database and count which are the most common words, this is what you would do. You would write a select statement to lowercase everything, and then you want to sum up each count of the words from the Shakespeare database. Then you want to group everything by the word, order by the count, and then go in descending order and give me the top 10. All right, then I create I import the BigQuery client library, I create the API client, and then I call it by sending in this job, which is this query. And what is my Google Cloud Project ID? Because BigQuery needs that, and then I show the results. All right, how many people have a guess? What are the most common top 10 words in all of Shakespeare put together? Probably you're going to say the, which is correct. And then maybe and. All right, there's not that many thous. A lot of people say thou, thine. Believe it or not that popular in Shakespeare. All right. So you can actually do this query inside BigQuery, and then of course you can download it as a CSV, but you can also, analyze the data, grab the data in whatever programming language you have and just analyze it. And I just dumped out the word and then the count. Okay. So BigQuery, very useful. A lot of public data sets besides Shakespeare, a whole ton. One of the very cool things about BigQuery is that it is the only product you can use in cloud for completely free with no credit card, no money, no billing. Everybody can use the BigQuery sandbox and issue up to 1 terabyte of you can query up to 1 terabyte of data every month for completely free. So all of you can do it right now. You sign into your Google account, you go to the BigQuery sandbox, and you can issue queries until you've queried 1 terabyte of data. There's a lot of public data sets. They will cost money for you to use them because you have to copy them into your project and use, we charge for the storage. But we have Google Cloud data sets. We have data sets from Google Research, and I think you can use Kaggle data sets as well too. We also have specific stuff for COVID-19. So if you want to analyze all of our, you can take a look at all of the COVID-19 data sets and run analyses on them. A lot of people don't know this is kind of outside of this talk, but we also have a life sciences API that basically is basically biotech, and it's just analyzing DNA and things like that. And then there's also a healthcare API, which is connecting data and different medical systems and transferring things. So we do have those things in case you get into the medical industry. And these are if you want to analyze COVID-19 data, okay? Because it's such a big thing and affects everybody. We're always trying to get more data out of all of this stuff. So BigQuery is very useful for that, okay? PubSub, I already mentioned, it's like Kafka. It's our mass message queue system. Cloud Data Flow is like Apache Beam. Basically, if you have a lot of data and you want to run it through lots of filters, MapReduce basically. So we have that service. It's basically, instead of you setting up your own VMs to run Apache Beam, you can just use data flow, just put the data in cloud storage, and then we manage it all for you. It's still Beam, but we manage all the infrastructure so you don't have to do it. So all the purple ones, I guess I color coded them. I didn't tell you. The purple ones are big data. And then what else do I have? The green ones are AI and ML. BigQuery is different because it has a little bit of AI ML. It has a little bit of big data. And it has a little bit of storage, which is blue. So now I'm going to talk about some of the storage ones. So cloud storage is your big giant data lake. You put all of your file blobs into cloud storage. That's like Amazon S3, if you ever use that. If instead of big giant blobs, you want like a file system in the cloud, that's Firestore. It's kind of expensive, so be careful. Okay, it's meant for enterprises that are looking for like a network address storage, network attached storage, a NAS system. Our compute engine VMs also have persistent disk. So if you want to boot from the same disk on all your VMs, you can use persistent disk for that. Okay, we also have relational storage, Cloud SQL. There's another one called Cloud Alloy DB. So Cloud SQL is basically SQL servers in the cloud, so you don't manage the hardware. You still have to request an instance to run MySQL, Postgres, or SQL Server, but we kind of manage the machine for you. You just tell us what kind of machine you want, and we take care of the hardware for you. If you need enterprise-grade Postgres, something that performs well and is faster, that's Cloud Alloy DB. I don't have a slide for that one, but that's the newest sort of like enterprise-grade relational database service. All right, so Cloud SQL is the basic one, and then Cloud Alloy DB, ALLOY DB, is our enterprise Postgres SQL service. Then if you want NoSQL, we had a data store called Cloud Data Store, are very fast, scalable, and then Google bought the Firebase real-time database company back in 2014. And from 2014 to 2017, they worked on merging these together. And now it's almost done. Okay, so they merged together. So now Cloud Data Store will have Firebase features. So now the new product name is called Cloud Firestore. and you can actually still use old Firebase if you want, or you can use Cloud Firestore if you have to sort of figure out the difference between choosing which one, because I really, really love Firebase. Maybe I want to use something newer. All right, so this is the difference between the Firebase real-time database and the Firestore NoSQL database that has some real-time features. And then Data Store became Cloud Firestore in Data Store mode. So if you're using Firestore, that is available in 2 different modes. You can use Data Store mode. So if you've been using Cloud Data Store all this time and you just want to stick with the same client library, that's Firestore and Data Store mode. But if you have like a, the traditional Firebase customer is using the storage as a backend as a service, so BaaS. So you have a lightweight front-end web client or a mobile app, and you just want to connect directly to the data store, to the database, because all of the compute is on the mobile device or on a lightweight lightweight web client like front-end JavaScript. Then you don't. Then you can use Firestore native mode because that talks just like Firebase. But if you have any kind of app running on a server or serverless, so if you're running on, so serverless is a third talk I'm going to give, or if you have an actual server like a VM, then you would be using data store mode. So this thing, this link tells you the differences between them. So either you're using Firebase or data store basically is what's going on. Okay, so that's that. I didn't talk about VMs much because I'm going to kind of like talk a little bit more about why you shouldn't use VMs in the next talk. But we have all kinds of VMs. If you do want a VM, you can get a free micro instance every month, all the way up to if you need a gigantic machine with 416 vCPUs, 12 terabytes of RAM, almost 256 terabytes of disk, whether hard disk or SSD, and you want to attach GPUs or TPUs to it. We support most major versions of Linux as well as Windows Server, so you can do that. But yeah, so that's if you have to have VMs. But I'll tell you why you probably don't want to get VMs yet, later in the next talk. We also have TPUs. So we all know that GPUs are mostly used to do machine learning model training, all right? But if you have to do a lot, it costs a lot of money and GPUs are hard to get. So if you actually try to get a cloud GPU, a lot of times we say we're out of stock because they're all being used because everybody's doing machine learning. You can also try and get TPUs. These are special processing units specifically made to handle, like TensorFlow, basically. So you can train models faster and lower cost using GPUs if you do a lot and you rent TPUs and attach those to your virtual machines. Okay. All right. So summarizing, machine learning helps you solve harder problems by making computers smarter. Well, one of my coworkers basically says it's basically using data to answer questions. So how do you do machine learning again? First, you get a lot of data. Then you build and train your model to validate it. And then you can use your model to make predictions on that data. But do you have to have a lot of experience with machine learning to get started? No, you can just use our pre-trained models. If you can make an API call, you can use machine learning. Maybe you don't have a lot of machine learning experience, but maybe you need to do training. Well, consider using AutoML. And then you can build your experience with machine learning until you are ready to use PyTorch or TensorFlow and your own open source library. When you are ready, when you have all the theory behind you, and you build up all the mathematical and statistical skills that you have to be able to do it on your own. Okay. So some resources to help you learn more about Workspace from the last talk, GCP from this talk. Now, what are your next steps? Try to use AutoML. Well, try to use our APIs first, and then try to use AutoML after that. Then try some of the code labs we have. So gcplab.me gives you all the cloud code labs. You can explore Kaggle to learn more about contests and other data sets. You can also consider, if you're going to be doing Jupyter notebooks, consider using Colab. It's free Jupyter notebooks, basically. There's a bunch of resources for students. You can look at those. Oh, I want to say something about the higher education, the teaching grants now. So this is, I'm done with the talk, but teaching grants is done on a per course basis. So you need to go and ask your professors and tell your professors you want to use Google Cloud in their class because you're going to do a lot of coding. and you're going to do a lot of machine learning, and you want to have free money. So get your professors to go to cloud.google.com/edu and register as a faculty member, and have a web page for the course and for their, their professor homepage, to prove that they're the teacher, the professor, and then apply for, you're teaching this class next semester, next quarter, next term, and I want to make Google Cloud available for my students. I want to give $50 for students. I want to get $100 for myself and for my teaching assistants. Again, you have to exceed the always free tier in order to incur billing. $50, I know it does not sound like a lot. Okay, but there's the always free tier is very, very generous. And we notice that across all the grants we've given out around the world, students only use less than 25% of the $50. They just don't use very much. Of course, a bunch of students will go over, but most students don't use much of it at all because, again, we have really good free tiers. The main idea is to not give Google your credit card or your debit card or anything, okay? So that's teaching grants, and only professors can ask for it. Students cannot ask for it, okay? Research grants are larger amounts, and you can consider them seed funding for research projects, and they last for longer than one term, okay? So for researchers, they can go to the same link and click and apply. Turnaround time is usually a couple of weeks, so do this well before the next term starts. All right, so to wrap up, I want to show you some fun stuff. So if you go to this link, quickdraw.withgoogle.com, you get to play this game where you have to draw a picture. So it tells you to draw a cup or something. You have 20 seconds to draw it so that Cloud Vision recognizes it's a cup. Okay, so it's pretty fun, so try it. If you want to learn more, so if you want to play it, go to this link. If you want to learn more about the app, go to this link at the top. There's another fun app called the Vision Explorer. And what that will do is this is a 3D, it's pretty intensive. You have to have a pretty good CPU on your laptop or your desktop to be able to do this, because this is all 3D. You can zoom in, zoom out. You can zoom in and see flowers. You can see sports. You can see plants, text, nature. So you zoom in and zoom out. It's like a 3D in space. So it's pretty awesome. Also uses Cloud Vision as well. And if you like comics, we have 2 comics for you that tries to make machine learning easier, because we know it's not easy. All right, so we have 2 pages. So cloud.google.com/products AI ML comic -1 and -2. So assume some of you know what Linux is, and you know this is shorthand for -1, -2, or -1, -2. Okay, and that is it. You already know about all these different tools. So let me just give you the long slides. So long slides are here. There's also a video for this. I gave this talk, I think, last year as well. Same thing goes for the progress bar. So take a picture of this one. Oh, if you're going to take a picture of anything, it's always the last slide, because I give you the link to the slide deck, a bigger slide deck, the longer version of this talk. And then I probably have a link to the video as well, and as well as the barcode to the this thing, the whatchamacallit. So, okay, so that is it for this talk. I'm going to hand it back over to the organizers to take a little break. I don't think we can take a full 10-15-minute break. Otherwise, we'll run out of time for the last talk. But yeah, we can take a little bit of a break so that people can go to the bathroom quickly and get a drink of water or something like that. So I'll hand it back to the organizers to manage the break. Thank you.
Okay, sir. It seems pretty easier to learn from you for the machine learning thing. Like at the start of the thing, only you have been describing making easier for machine learning. It was good to learn topics about the BigQuery thing, the big data, the PubSub sector and all. It was pretty fun at the end by describing the comics and the books and the applications which we will be looking forward to get in touch with the participants to interact more with this slide. And we will be sending it as soon as it will be received from your side on the email section. It was a great session for the second time also. So this time we would take only a 10-minute break for the third one to start, so that we can finish it as soon as possible. It was great. So all the participants, please fill out the feedback forms. It's been great that you have been such a support for the 2 sessions, and you will be present for the following the third session and all. Thank you very much, sir.
Okay, I'll see you all in 10 minutes.
Yeah, so the 10 minutes break ends now, right? We are into our third and the final session for today's workshop. It's upon the serverless computing with Google Cloud, and I will hand over to our guest, Mr. Weasley, to just done the last session. And yet again, we can see your screen over there. You haven't started your laser yet. We can just see the cursor right now. Okay, yes. It has arrived.
Okay, great. Thank you, Narav. All right, last one. I don't want to keep you from lunch because I'm the thing holding you from eating. So I don't want you mad at me. So I'm going to go pretty quick. Fortunately, there's not that many. Well, I should say I'm optimistic that I can finish this quickly. So let's do that. We're not going to talk about me again. So similarly, cloud computing has kind of like taken the industry, maybe all industries by storm, right? Because you can use cloud computing in any industry, right? App modernization is one of the top priorities at many large companies or even small companies. And app modernization just means that I need to containerize my apps. They can't just run code on machines anymore. I want to get them onto VMs because if I get them on VMs, now I can run VMs on different hardware. Or if I have it on VM, I can move the VM straight to the cloud. Okay, so yes, Google can give you a lot of VM and a lot of big disk. So why serverless? So serverless lets you focus on your solutions that you're building for your customers and not what they run on. And really to help you understand, as the next generation workforce, how to become cloud aware. It's not always just running on machines anymore. It's not just running on VMs anymore. Serverless is a big deal. All right, so I'm going to give you a quick review of cloud computing. Then I'll very quickly go through a Google Cloud intro again. Then I'll spend most of our time talking about serverless. And then, we've already done the inspiration, so we're not going to spend too much time there and then wrap up. Okay, so this will go pretty well and pretty quick. So this cloud computing overview, just like for the machine learning talk, that has nothing to do with Google. All right, machine learning is machine learning, regardless of Google or any other cloud vendor. Okay, so similarly, cloud computing covers all cloud vendors, not just Google. Okay, so what is cloud computing? really you're just outsourcing something. You don't want to buy and manage it yourself. So I'm outsourcing a hardware. I'm outsourcing big disk. I'm even outsourcing applications. And probably the most well-known one that we know about is email, because a long time ago, when I was young, in order to send and receive email, you have to have a workstation in front of you, and you have to have an email server running on it so that you can send and receive email. As the internet became more global, and everybody got computers, you should not expect your grandmother to maintain SMTP on port 25 in order to send email. That's unreasonable for regular non-computer oriented people, right? So we outsource our email service to cloud vendors that are well known, like, for Yahoo Mail, Yahoo, you outsource to Yahoo. If you're using Gmail, you outsource your email service to Google. If you're using Hotmail, you outsource your email to Microsoft. All right, so those are examples of outsourcing applications to the cloud, because now the cloud vendor has to have a machine that's running 24 hours a day, 7 days a week, running those mail servers so that you can always get and send email. Okay, so that's that. So in the cloud industry, we break things down into 3 categories of service. Okay, so these are service pillars or service levels. Okay, and email is an example of software as a service. So these are applications that you have outsourced to the cloud. So such as email and anything workspace, right? All, doc sheet slides. You've outsourced your word processor to the cloud, your spreadsheets to the cloud, your presentation software to the cloud, Office 365, Salesforce, right? Anything that you have to log in with a web browser or your mobile app is a SaaS application. Okay, notice that when you're using SaaS applications like Gmail or Yahoo Mail or whatever, Office 365, you do not care what language it's written in. You do not care what kind of virtual machine it's running on. You do not care what the operating system is. You do not care what database server it uses. The only thing you care about is that you can get your email and you can change your email settings anytime you want. Okay, you want to be not restricted. So SaaS apps give you the freedom to not have to think about it. Okay, all right. So at the very bottom level is the infrastructure as a service. This is a lot of, most people think this is cloud computing, where you have virtual machines and big disk, right? So like, Amazon has EC2 and S3, Google Cloud has Compute Engine and cloud storage, and then Azure also has the same thing. So this is where you are outsourcing your raw hardware, okay, and big disk. Okay, and so most cloud vendors have infrastructure. Okay, now one thing I want to say is that if you are outsourcing this hardware, you're saying, I don't want to buy this anymore, I want to borrow it from the cloud. That's great, but if your purpose of getting infrastructure is to run applications on it, your job is not done, because once you rent the machines, you have to pick the operating system. You have to decide, do I do Linux? Do I do Windows Server? If I do pick one, which one do I do? If I do Linux, which distribution, which kernel version? If I do Windows Server, do I do Windows Server 2018, 2019, 2021? Which one do I do? You have to decide that. Then after that, you have to get all the software patches, all the upgrades. Then you have to get the web service. Which web service do I use? Then you have to get the database server. Then you have to have the load balancers. Then you have to configure DNS, all to run code. Too complicated. If you just want to run an application, you shouldn't have to worry about all those things. So that's why we have platform as a service, because now you're just outsourcing your code. This is app hosting, function hosting, okay? Basically hosting logic, your computing logic, all right? So with App Engine or Heroku or AWS Lambda, you're taking code, you're uploading it to these systems, and then the cloud vendor runs everything for you. They get the VMs, they get the operating system, they get the web server, they get the database server. You don't have to worry about that. All right, so that's why platform as a service is very useful for developers. okay? Because we don't have to worry about the sysadmin, the DevOps, and all those things, okay? Now, what's interesting is, remember how we were talking about SaaS, right? You're using Gmail. If you find a bug in Gmail, what do? You can't fix it because it's not your code. You have to file a bug with Google and hope that one of our engineers fixes it, okay? Why am I telling you that? The reason is because if you use a PaaS system, guess what? You're giving your users a SaaS app. Now it's your code. If your users find a bug in your application, they have to file a ticket with you because they can't access your code. It belongs to you, right? So you use PaaS systems to host SaaS apps with, all right? And your users don't care what language you use. They don't care what operating system it runs on, right? Because they're using a SaaS app. For you, you may care about some of these things, but you know it's taken care of for you. You don't think about the operating system. You don't think about the database server. You just use whatever cloud services are available, right? Okay. All right. So those are the three major cloud service levels. Now, with all large ecosystems, you're always going to have a little gray area in between. You know, a little bit of this, a little bit of that, right? So in between infrastructure and platform as a service, we have, you know, it's not raw hardware or big disk. It's more than that. But it is not a platform that you can upload applications to and run it, right? So these things typically are going to be like data services, like databases, data analytics, data processing. There's also networking. There's also containers. So things that are more than hardware and big disk, but not a PaaS system. Okay, so that's this level. Containers come to. Between PaaS and SaaS, it's a very small, I know it's the same size as all the other ones, but it's very small. This one is PaaS systems too, except for one thing. The PaaS systems that you see here rely on you having data that live at the SaaS level. So in other words, you would only use Appscript, which I introduced to you two talks ago. Yeah. If you had Workspace data and maybe Google Maps data and maybe other kind of Google data, and then you would only use Force.com if you had Salesforce data. Because if you didn't, why would you use these restricted PaaS systems when you can use something more general purpose like these PaaS systems here? Okay, so these are what I call restricted PaaS systems, because usually you're only going to use them if you have the that SaaS data. If you don't have the SaaS data, don't even bother. Just go with these things. Okay, so these are the three levels of cloud computing service, and the gray areas in between each one. Now, if we were to take the same picture but look at it from a slightly different perspective, a different angle, a different opinion, and instead of this, which is the services, you're looking at it from who is responsible for what. That picture looks like this. So if you're using SaaS, you've outsourced the whole application. You don't care about anything. You're not responsible for anything except maybe, you know, like if you're using email, you're responsible for your email settings. That's not listed here. That's higher on top of the applications, right? Your email signature, your out of office responder or whatever, okay? So you're responsible for basically nothing. If you're using a PaaS system, you're hosting your app and the data that goes with that app. So you're responsible for the code as well as for the data, but everything else you've outsourced. If you're using infrastructure, we give you the hardware, the VMs. Now you have to decide the operating system, the database server, the web server, and then your application data. So everything from the operating system level on up, that's what you're responsible for if you use infrastructure. And then if you're not using the cloud, you're on premise, it's all your machines, so you're responsible for the hardware and everything else. So you're responsible for everything, basically. So managed by you is in blue, managed by the cloud vendor because you've outsourced it is in gray. Okay, so this is same picture again, but different opinion, right? This is based on who's responsible for what. So anyway, so this is a very generic overview of cloud computing. So hopefully everybody understands. So now we all know what we're talking about, because usually when you say cloud, everybody has a different idea of what cloud is. And so the purpose of this part of the talk is so that everybody has the same vocabulary, everybody uses the same words, everybody has the same understanding as to what runs at what level. Okay? All right, so now we can talk about Google Cloud, but we're probably not going to talk about it because we've already done it. So we can skip through this section real fast. That's a data center. You're a customer. Okay. Here's a new slide. Why would you use Google Cloud instead of other clouds? Well, we have 9 products with more than 1 billion users every month that run on our cloud, and they can't go down. So we have to make sure our cloud stays up. So typically our cloud has fewer outages than other clouds do, but it's because we really care about our own products, right? These services that you already know shouldn't go down. So we have a lot of staff whose purpose is to make sure they stay up. Also, we have a very green cloud. So we're very good at using energy, try to be carbon neutral, use as little fossil fuel generated energy as much as possible. I also haven't shown you this slide. This is basically showing you how we have out of this world scale and innovation, and also security. See, we have a, it's really funny is that when you have a picture of a Google data center and it's taken by a professional photographer with professional lighting, it looks so impressive, right? But if you actually go into a data center, it's just gray, loud because there's fans blowing, not really exciting because we don't set up professional lights like a photographer does, right? But we have good security. That's the most important thing. So if you want to learn more about Google data centers, I have a lot of links here. A lot of them are kind of old. It's fair. We don't expose a lot of our data centers to the public very much because it's all very proprietary. Custom motherboards, custom networking setup for very, very, very fast speeds. Custom components that we use, we build. But you can find out as much as you can from these links here. All right, you already know what Google Cloud is: cloud platform and workspace. So all the serverless tools live under cloud platform. You already know about workspace. Now, where does cloud platform and workspace fit into our overall cloud computing picture that I just told you about? Well, anything that's SaaS flavored is going to be workspace. So I introduce you to all the workspace tools and their APIs, and I introduce you to Appscript. So that's all workspace, and everything else below that is cloud platform. Or we just call it Google Cloud now. We don't even say platform, although everybody still says GCP. Okay. So in GCP, there's lots of compute that we offer, from VMs to orchestrating VMs using Kubernetes, all the way up to some of these other ones. So in this part of the talk, I'm going to focus on the ones that are hands-free, no touchy, no thinking about instances, no thinking about nodes. So that's what we call the fully managed services. So Cloud Run, App Engine Standard, and Cloud Functions. App Engine Flexible is like Compute Engine. So they're VMs, but they're managed VMs. And we scale for you like the way App Engine does, but it's explicitly using VMs. So you can actually use App Engine Flexible, or you can use Compute Engine with what we call managed instance groups. They're really almost identical as a product. Or you can actually, if you're using Docker with App Engine Flexible, then you can actually run it on Cloud Run. So anyway, I'm not going to talk about all those things. We're only going to focus on the gold ones here, okay? Because these are the ones where you really don't think about hardware, VMs, or anything like that at all, okay? So if you want to see this whole chart, you just go to this link down here. All right, so serverless. So yes, we have big, we have VMs, we have big disks, but why? So I showed you in the last slide, or in the last talk about Compute Engine. We have all kinds of VMs, and we all have giant disks where you can put terabytes of data. But why would you do this if you want to host and run applications with? Because now you have all these other things to worry about, like operating systems, database servers, web servers, load balancing, DNS, networking, subnets, Kubernetes, all of these things. You have to worry about all those things. You just can't upload code by itself. So that's why we have serverless. Okay, so serverless, of course, is a misnomer or a lie, but we don't like to say lie, right? That's a bad word. So we like to say a complicated English phrase like pedagogically motivated misrepresentation. All right, but it's a lie because it's not really serverless. There are servers, but the main idea is it's not for you to worry about. You let the cloud vendor worry about the servers. You just focus on writing your code and solving business problems and making money and getting rich. Okay. Concepts of servers and nodes and instances, whether they're physical or virtual, are abstracted away from the user, the developer, so you don't think about those things. Why should you be interested in serverless? Well, according to analyst research, and these analysts, I think, are actually based in India. So, once you get the slide, you can click on it and read their research. Okay. But they have concluded that since 2016, the amount of money worldwide that has been being put on serverless is growing by almost double every other couple of years. Okay, so in 2016, it was almost $2 billion US, which is a very big number to think about. And then in 2018, it was 4.25. 2021, it was almost 8. Then it's projected to be next year to be almost 15. And then by 2025, 21. That's one analyst. Another analyst measured 4.18 in 2018, which is close to this one. So they're not too far off. And then 2020 was 6 billion, kind of close to the 8 billion for 2021. 2026, they estimate 31, which is a big difference between this one and 2025. And then they further estimate that in 2020, it'll be 53 billion. So it is the fastest growing segment in cloud, or one of the fastest growing segments in cloud. So that's one reason why you should learn about serverless. Plus, as a student, you don't want to pay for VMs anyway. It costs money. You don't have money. You're a student. Even when you graduate, you still don't have money. You have a little bit of money, but you don't have a lot of money. Okay. But maybe you want to start a company, and maybe you can't start the company with a lot of money. So serverless is good. Why is it good? Another reason why it's good, because if you build something amazing and you go viral, and let's say you were buying your own hardware, but you didn't spend enough. So while your initial users are happy because your app is really cool, when you get thousands and thousands and millions of users, now your machines that you bought, you didn't buy enough. Now your new users can't reach your app. And worse, your existing users can't reach your app. So now your company is not going to do well. Okay. Our cloud products, at least the ones on the cloud platform side, are auto scaling. They will automatically scale depending on the traffic that your app is getting. So if you go viral and go crazy, our machines will keep on creating instances for you automatically, so you don't have to worry about it. One of the most interesting use cases was, I know you all are very young, but when you were babies, about 11 years ago, there was the first royal wedding from England. That app was an App Engine app, and it was running during the wedding. And, we were getting, 5 users every second hitting the app. And then as the wedding got on, and then, then it became 10 users a second, 20 users a second, 50 users a second, 100 users a second, 500 users a second, 800, 1,000, 1,300, 3,000, 5,000, 8,000 users per second. App Engine just scaled. Didn't go down. And then as the wedding finished, these servers got taken down automatically, reduced it down to how many instances, and then less and less traffic after the wedding is over. And then finally, very few people are using it. Okay. So if you go viral, auto scaling is your new best friend. Now, when you graduate and you get a job, your manager will tell you as a software engineer, solve for the 80-20. Do 80%, handle 80% of all use cases, leave the corner cases, edge cases for V2 later. Going viral is one of those edge cases, automatically handled for you. The other edge case is maybe your company spent too much money buying hardware and didn't use enough money to hire good engineers to build a great solution. So now you don't have any users, but you spent all this money. Well, that's also not good for your company either. So if you go viral and you didn't have enough hardware, then that's a bad ending. If you spend too much money on hardware and no visitors are coming, you're not making money. That's also a bad ending for your company too. So what if you don't go viral? What if very few users come? Well, one of the other good things about serverless is that it auto scales to 0. If you have no users, then you're not getting any traffic, which means you have no instances running, which means you're not incurring billing, which means you're not paying, because it auto scales to 0. If you're renting a virtual machine or a real machine, you're paying 24 hours a day, 7 days a week. Even if you have no users, you have to pay, but not serverless. So it handles the other edge case, the one edge case of going viral and auto scaling, and the other edge case of no users, auto scaling to 0. So those are 3 really good reasons why you should learn serverless. Okay. All right. Now, where does serverless fit into our overall cloud computing pattern, right? Because when you use Google Cloud SQL, that is a relational database that you don't have to manage the instance. You just tell us what you want and we do it for you. That's serverless too, because it's not your server. You're not managing it. You're just telling Google Cloud what server you want, and we make it for you, however many you want. But when I say serverless, I'm talking about serverless compute, which is just this middle one. Okay, all these other things are serverless too, like our machine learning APIs, that's serverless. You're not using servers unless you're using Vertex AI and you're saying, I want 5 instances with GPUs. Okay, yeah, that's not quite serverless, but it is because it's not your servers. We allocate it for you, just like Cloud SQL. All right, so all these things are serverless, but when I say serverless, I'm talking about serverless computing, okay, which is all the dark orange stuff. Okay. All right. So first product is Google App Engine, our first cloud product, launched in 2008. This is our app hosting in the cloud service. Okay, and there's a homepage for it there. Why does it exist? Our original product managers in the middle of the 2000s, like 2005, 2006, went around to all these companies and said, what is the hardest thing? What is the most difficult thing to launching a global web service? They said, we don't want to worry about VMs. We don't want to worry about monitoring. We don't want to know about operating systems, web servers, load balancing, databases, configuration. We just want to write code. We don't want to upload code. And by the way, can you manage all that for us? Can you also make it auto scaling? Because if I go viral, I don't want to go out of business. And can you only charge us if it's being used? Because if I spent too much money on hardware and nobody came, then I'm going to go out of business. But if I'm using serverless, please don't bill me unless I have users. And also make this tool available in lots of familiar programming languages so I can write my solutions. And give me a local development server so I can test it before I upload to the cloud. And give me a database and some caching and external execution tasks, and give me big file storage. Okay, so the App Engine team took all these little brown boxes, jammed them into one giant box called App Engine, made it available first in Python, then Java, then Go, then PHP, and then finally Node.js and Ruby. Here's the world's smallest web app in Python, so we call this the MVP, or minimally viable product, the world's smallest web app. You need a config file to tell it what language, what version. You need a third-party packages file, like what files do I want to install for my app. In this case, it's a Flask web server. And then I have the world's smallest web app here, which is if I go visit / on a website, it gives me hello world. If you download the Google Cloud SDK, now you have the gcloud command, and I have my source code. I have these 3 files in my folder. I can say gcloud app deploy. I log in. I tell it what region. And then in less than 60 seconds, my app will be available around the world. So my cousins in England can reach my app. My grandmother in UP can reach my app. At a domain name and for free. Of course, if you start a company and you want your own domain, you can also do that. But this is basically the Python Quickstart, and we have Quickstarts, of course, in all supported languages. Okay, so that is App Engine. Okay, heads up, not all apps have users with a website. You can have a mobile app and you need to save some stuff, like maybe you're writing a game and you want to save high scores and contact information or levels or badges and things like that, because if you have a game and your users get really high scores, and then they go to a party at school, and then their phone got destroyed or lost or flushed down the toilet, and then they buy a new phone and install your game again and log in, and they don't see their high scores, they're not going to play your game anymore, right? So you need to store some data away from the phone, away from the device, so that if your user installs your app on a different device, they can get their environment back. Okay, so not all apps on App Engine have a web page, right? It could be just for the mobile app to talk to the cloud and back things up to the cloud. So just be aware of that. You can have a web page if you want to, but you don't have to. Okay, it just gives your users a better experience, right? I know these phones are pretty old, right? iPhone 1, that was a long time ago. Okay, so anyway, so that, just keep that in mind. So App Engine has a lot of use cases. By the way, this is not just App Engine. All of our serverless tools have a lot of different use cases, a lot of mobile backends, a lot of gaming, a lot of social apps, unpredictable traffic consumer apps, for you students, student apps, right? It's free. All of our serverless tools have a really generous free tier, so you're probably not going to pay for it. A lot of small businesses run their business website on App Engine, and they've never paid Google 1 penny or 1 rupee. Okay, so the free tier is pretty generous. And then, of course, business apps as well. Okay, so that's App Engine. Our second serverless tool is called Cloud Functions. So this is like AWS Lambda if you ever used it. This is function hosting in the cloud, because maybe you don't have an entire app, or maybe you don't want to worry about frameworks. Oh, I need to build a LAMP stack. Oh, I need to build a mean stack. I need to have a web framework. Maybe you just have a small little bit of code that just updates a database. Well, I don't need a full framework like Django or Spring to do that. Okay, I just want a little bit of code running online. So that's what Cloud Functions is for. You can deploy little utility functions. You can break apart large monolithic apps into multiple reusable pieces. Like this is the component that reads and writes from the database. This is the component that does user authentication. This is the admin stuff. You can actually break apart a large app into multiple pieces and then use them or reuse them for more than one app, because now you've split it up into different functionality, right? You don't have to write a giant app every single time. Okay, so that's what Cloud Functions is for. Now you can call Cloud Functions using HTTP just like App Engine, but Cloud Functions does a few things App Engine cannot do, and they are bolded, bold this, right? So one of them is background events, and I talked about this in the first talk. Remember, my colleague wrote an app that helps you analyze Gmail messages. Well, he didn't run the code by going to a website. What happened was, when he got a Gmail message, that sent a notification to PubSub, which called the Cloud Function. So PubSub can call a Cloud Function, or maybe somebody uploaded a file to cloud storage, or maybe somebody logged into Firebase. All of those things can trigger execution of a Cloud Function. You don't have to just HTTP to it from a web browser or from a mobile app, okay? But like App Engine, Cloud Functions is auto-scaling and highly available, and you're only paying if somebody's calling your code. It also has a flexible development environment, so you can code on the command line just like with App Engine, but you can also do it in the Cloud Console. Everything. You can create a Cloud Function, code the Cloud Function, deploy the Cloud Function, and test the Cloud Function, all from the Cloud Console. Okay, and you can't do that with App Engine. But if you do like local development and test, we also have the functions framework that helps you with that. It provides tools so that you can actually test your functions locally before you upload to the cloud. By the way, there's two icons here because we have two different Cloud Functions products. We have regular Google Cloud Functions, but we also have a Firebase version. So Firebase, as I kind of told you a little bit, is our mobile development platform. So if you're working on an Android app or an iOS app and you're using Firebase, Firebase not only has a real-time database, but it has all these mobile development tools. And if you're writing a mobile app and you need to take advantage of all these Firebase tools like like deep linking, app indexing, mobile crash test reporting, virtual device testing, all the different Firebase tools to help you build a mobile app, and you want some code to run in the backend from mobile backend, basically, you would use Cloud Functions for Firebase because it's connected to the whole Firebase ecosystem. But if you're just doing stuff in the cloud, then use regular Google Cloud Functions. They're very similar. Okay, the one difference is while Cloud Functions supports all of these languages, the Firebase version only supports Node.js. So you have to do everything in Node.js if you're using Cloud Functions for Firebase. So that's the one big difference. Okay. Here's your minimally viable product, MVP, very short, even shorter than the App Engine example, because this is a one-line application, just prints hello world. Because you don't have a config file, your deploy line is a little longer. But just like with App Engine, in under 60 seconds, you can curl to it, hit it with HTTP. And if you, trigger it a different way that's not HTTP, like you pub sub send a message or cloud storage upload or something, that will trigger the cloud function. But this one is HTTP because I told it that I'm going to kick off this function only with HTTP. You can only pick one trigger type. Okay, and this is basically your quick start in cloud functions in Python. But again, all these other languages also have quick starts as well. Okay, just heads up. A couple of months ago, we launched Gen 2 of Cloud Functions. It's currently in public preview. It's not generally available yet, but you can do it. So the main idea is you have more processing power, you have bigger instances, more memory, more CPU. You can run for longer. Okay, so yeah, so that's coming up basically. All right, last product, Cloud Run, container hosting in the cloud. It has a nice short URL too. So over the last 10 years, while you all were growing up, going to school, getting into university, containers became a big thing. Docker became a big thing. And it doesn't have the same restrictions as other serverless tools like App Engine and Cloud Functions. You're restricted to these languages. In fact, Cloud Functions has a few more languages that App Engine does not. So C++ and C# and Dart are languages that are not supported by App Engine. But even with all of these put together, even Cloud Functions, this is like what, 3, 5, 6, 7, 10, right? You still can't do C or Rust or Haskell or other languages, Perl or whatever, right? So maybe I don't want those restrictions. If you have a container, you can pick whatever language you want, right? So any language, you can use any library you want. And because it's your container and you're, we have some security, but now you're deciding what goes in the container, you can do binaries, okay? So it has much fewer restrictions. Docker has a huge ecosystem of different base images you can start with, some for WordPress, some for machine learning, some for this, some for that. And really, containers have become the industry standard. There's containers for everything. And because they're the most flexible. But a lot of people really like the convenience of serverless, right? Because serverless, you just upload the code and you run it. I don't have to think about anything. But with serverless, you have the issues of, it doesn't have the language I want to use. Maybe I want to use a binary, And if I write against, proprietary APIs like App Engine's original APIs, you can't run that code on any other platform except for App Engine. Okay, we can't be locked in. Why do I have to choose between the flexibility of containers versus the convenience of serverless? Why can't I have both? Okay, and that's what led to Cloud Run. So Cloud Run is containers. So that means you can have any language, any library, any binary. The only thing we ask of you is that you leave one HTTP port open in your container so that our Cloud Run service can call your app in the container. And you also have to make it stateless. So now you can no longer bundle a database in there. I mean, you can bundle a database in there, but that's not the purpose of serverless. The purpose of serverless is to do request response very, very quickly. If you want to have some kind of data storage, you should use a cloud database. Don't put a MySQL in your container. Call Cloud SQL. If you want NoSQL, call Cloud Firestore. If you want caching, use Cloud Memory Store. Use a cloud-based storage mechanism for your state. Don't put it in your container, okay? If you are able to follow these two rules, okay, then you can build your container. If you're familiar with Docker and you know how to do containers with Docker, sure, go ahead and do that. But if you don't know any Docker, you can use Cloud Build. Okay. In either case, they will both create a container for your application, and then it will automatically deploy it to either the container registry, which is the old one, or the artifact registry, which is the new one. Once it's in the registry, then you can deploy it to Cloud Run or other cloud services like Kubernetes engine. Okay. Another cool thing Cloud Run can do is it can also support push to deploy from Git. So as soon as you check in your source code into Git, it can trigger the building of your application in the container, uploading it to the registry, and then deploying to Cloud Run all the way. And if you want to add automated testing, which is a CI, continuous integration, you can add a service like GitHub Actions, which will actually do that for you. So it'll run all the tests, and if all the tests succeed, then it will trigger the build of your container image, put it in the registry, deploy to Cloud Run. So you can build all that. So you can click on these links to learn more about how to do that. And the best part is if you've ever done Docker, it's not that easy, especially the Docker files, because it can go crazy and you can build bad layering and you can build a very inefficient container. So build packs makes it so that you don't have to know anything about Docker or Docker files. You just deploy it like App Engine and Cloud Functions. You just do source code and it does everything for you. Okay, so here's your Python MVP. It's pretty much the same as the App Engine version. There's a small difference. So App Engine and Cloud Functions give you a web server, but now that you're doing containers, you have to bundle the web server with your container. So that while most of the lines are the same as App Engine, so the package requirements file and then your application, there's a few extra lines that are grayed out down here. Okay, and also I need an extra import here. In case you forget to bundle a web server in your container, this will run the one that comes with Flask, which is the development server. So these two lines are just in case you forget, because now, again, this is a container, so you have to actually put the web server in it. Okay. All right. So as I also mentioned, because you have a container, typically you need a Docker file. So Docker file is like, I'm going to have a operating system. I'm going to pick Linux, something, and then I want to have minimal container, just support Python apps. And then I'm going to make an application folder. I'm going to copy all my source code in there, and then I'm going to install the Flask package and whatever I have in my packages file, and then I'm going to run my web app. So this is how you start up your container. Then you should also have a Docker ignore to say, don't bundle all these extra files in there because they don't have anything to do with my app, and I don't want my container to be too big. All right, because it'll slow everything down. So Docker ignore says, don't put all these things in your container. Now that you have these two things, you could say Docker build and Docker push, or you can be lazy and do the one-line version, Google gcloud build submit, which will build your container and put it into the registry using the URL here, or the tag that it's called. And then once you have that in the registry, then you can run it or do Docker run or gcloud run deploy. It'll take that same image that you put into the registry, and then it will launch, put that on Cloud Run. It will launch it with the service name that you give it, and boom, you're done. You can do that, or you can be even lazier and like, I don't want to type 2 commands. I just want to type 1 command. So you can combine them both into this one step, which is gcloud run deploy service name, and then you say deploy by source. Don't automatically build my container. I don't want to build the container myself. I want you to do it for me. Okay, either one, either these two or just this one, it's fine. Once you're done, again, just like App Engine and Cloud Functions, in under 60 seconds, your container is available globally at a special URL. Okay, and then, like I said, guess what? Now you don't even need to have Docker file or Docker ignore. Well, maybe you could have a Docker ignore, but you don't need the Docker file. Okay. Because Cloud Build Packs takes care of that for you. So Build Packs works like this. If you don't know Docker, but you still want to build a container, there's this open standard called Build Packs from the Cloud Native Computing Foundation, and Cloud Build Packs from Google adheres to this standard. It follows this standard. And Cloud Functions also uses this as well too. And so if you write your code, if you're using Go 1.10 and newer, Node 10 and newer, Python 3.7 and newer, Java 8, 11, and 17 now, .NET Core, C# 3.1 and newer, then you can use build packs and not do a Docker file. So here I have a Node.js Express app. Here I have a Python Flask app, just like the minimally viable product, the MVP. But notice my commands are the same. gcloud run deploy, my app is the name of the service, and then -- source or hyphen with a dot, which is current directory. It goes into your code. It figures out, oh, you have package.json. That means this is a Node app. What version of Node? I'll check to see what's the latest I have. Or I have requirements.txt, which means it's a Python app. So it goes into your source code and figures out what language it is, because it can see .js, package.json, or .py, requirements.txt, and it figures out what language, one of these supported languages, and it builds it. So it doesn't matter what language it is, as long as it's one of the supported ones, you can deploy it to Cloud Run without knowing about containers, Docker files, any of that stuff. Okay, so very, very useful. Okay, cool. So that's it. A lot of people ask, when do I use App Engine for what? When do I use Cloud Run? When do I use Cloud Functions? What's the difference between the three? There really is not much difference between the three. Use cases slightly different. Okay, so this chart is not hard-coded. It's most likely, I see users and customers doing these, but you can probably put checkboxes on other places. It's very flexible. Okay, it's I'll give a demo at the end if there's time, but it's so flexible that I wrote an app that is nebulous, right? It's cloud, it's nebulous, right? And it's so flexible that this app, it's actually a demonstration of how to use the translation API. Okay, it's so flexible, I can run it locally on the server, whether it's Flask on Python or Express with Node. It can run locally. It can run on App Engine, Cloud Run, or Cloud Functions with no code changes. The only thing you change is the configuration, and that tells it which one you want to deploy to. Okay, so you can learn more about this app at this link here. That's the blog post, but I'm starting to release videos. So a video just came out 2 days ago, which is the first video for this app. But anyway, so take a look at the blog post. So this, if you play around with this tool, then you can learn how to deploy the same app to all three. So you can learn all three and decide which one is better for your student projects. Okay, on Appscript we already talked about, so I'm going to skip past all this stuff and wrap up. Okay, we already did all this. Yay, going fast, fast, fast. These are all serverless tools. This is just Workspace serverless, by the way. I covered mostly cloud serverless, GCP serverless. This is Workspace serverless. Okay. Okay, so wrapping up. Serverless, what's the cost? I already told you about free trial and always free. Specifically for the serverless tools, App Engine gives you 28 hours free per day. Okay, you get 1 GB of storage and 1 GB of network outbound networking per day. Cloud Run and Cloud Functions use per month, so it's slightly different because they're newer. You can make 2 million calls to Cloud Run or Cloud Functions every month. You get a certain amount of RAM seconds, like how much time can you allocate seconds. And then you also get vCPU seconds. How many seconds of CPU are you using? And then you also get, 1 GB of outbound networking or 5 GB of outbound networking per month. So it is not as generous as App Engine, because App Engine gives you 1 GB a day. So, but honestly, when you look at the overall cost, Cloud Run and Cloud Functions are overall cheaper actually than App Engine. Okay, because they're newer, they're built on a newer stack, and so we've made it cheaper. Okay, and then I already told you about the higher education grants. So summary, why go cloud? Cloud computing is taking the world by storm. You're kind of behind if you're not already using it, but it's not too late. Really, it wants you to be the part of the next generation cloud ready workforce where you know about these things in addition to VMs and things like that. Google Cloud, why Google Cloud? Well, of course, we have lots of different features, just like other clouds do. Modernization is just more than moving VMs to the cloud. We want you to think about serverless as well too, because it lets you focus on just your code and your solutions and not on what they run on. Okay, and of course, there's a lot of interesting possibilities if you use more than one Google product. Okay, so you know about all the different other APIs we have. Okay, and then we have a lot of references for you to look up, code labs and things like that. And then this is it. So these are the slides. I'm going to come back to this slide in just a moment. There's a video as well too. I'll come back to this slide. The reason is because there's one more presentation, just 2 slides I want to show you because it's related to student stuff. So I already told you about the education grants, but there's a couple of things that I want you to know about for students. So in addition to your degree that you're getting from your university, you can also get a certificate. So we have ways for you to go and get a certificate, but you need to have your professors involved, okay? Because your professors need to get trained on how to do this certification. Once they're trained, then you can do it, and then you can do it for pretty much 100%. You know, everything is free except for taking the test. So you get a 50% discount on your test. If we don't charge money for the test, then nobody's going to care. It's not going to be worth anything, right? So we charge some money, not too much money. I don't know exactly how much money, but maybe like 100 and something, 150 US dollars or something. Not a lot of money. You know, it is money, okay? But you're getting a certificate, which means if you take your degree plus the certificate, it really shows the companies that you want to apply for a job that you're really ready to get going. You already know cloud and you know it well. So you get free training on Coursera, free training with Quick Labs. So just go to this link. It'll tell you how to get your professors to do it, because you have to be sponsored by a professor. Okay, so that's one thing. Also, if you're considering a technical career, you know, software engineer is the main career that we have at Google and other big tech companies, but it is not the only one. So you notice that my title is called developer advocate, right? It's listed here. It is a software engineer with social skills. So if you're good with talking to people, you like teaching, you know, we are a different kind of software engineer. We build code samples for people. We help customers build their apps, their solutions. We help other users learn how to use our APIs. So it's slightly different. Then there's all kinds of other jobs that you can use your technical degree at Google. This is Google. So all these links are links to YouTube videos from a Googler who actually works in one of these positions, and you can learn more about their job. So just don't think that software engineer is the only kind of job that you can get. Yes, you should probably be a software engineer first, so you have the basic skills, and then you can do some of these other ones, but you don't have to. You can go straight to be doing hardware. Maybe I'm not interested in software. Maybe I want to do hardware and design chips and things like that. But guess what? As a hardware engineer, it is advantageous if you know how to code, because then that makes you better or more likely to be hired than another hardware engineer that doesn't know how to code. So coding is important no matter what you decide to do in your career anyway. So this is just 2 slides, but I'll add this PDF, this 1-page PDF that has 2 slides on it. I'll send that to you separately, but just wanted to give you that. So you have all these links. You can go to these student guides, technical development guides, a sample technical interview, and learn other things that we have for students, okay? Because you guys are students, these are special slides that are only for you guys, not for working professionals. So I'm going to stop here so that you can copy the, take a picture of this slide so you can get the long version of this talk, or you can wait until I send the PDFs for these exact talks slides to the conference organizers, okay? So I'm going to hand it back over to the conference organizers. I don't know how much time we have for questions, but if there's no time, that's fine. I can take questions by email as well, so the organizers know my email so they can send it to me, or you can drop it into this Google Doc. I don't think I've created an entry for the hackathon yet because you guys haven't gone to the hackathon, but I will be adding one very soon so that you can drop your questions in there maybe next week. Okay, so thank you very much for dealing with me for so many hours. And I will hand it back off to the conference organizers. So thank you very much for asking me and inviting me to come give you this workshop this morning. So please go get some food and don't be starving.
Yes, sir. So thank you very much, sir, for this wonderful workshop that you have been given us. It was a beautiful Saturday morning, straight away from 9:30 until the lunch break till now. We have learned a lot of things based upon the topics that you have been teaching us from on. It was a wonderful learning experience. So let's conclude this workshop. Thank you guys for attending. We hope everyone enjoyed, and we look forward to see you in the next event as well. We have shared a feedback form link. Please fill the form to tell us how much you like the workshop, or if you want us to improve in any aspects. The form will be followed by your details, using which we can get your certificates ready. So please make sure that you fill the feedback form, please. Please register for the hackathon if you have not done yet, and also join the Discord as it's mandatory. so that you can get further informations about the event and stay connected with social media to stay updated. That's it. Let's end the workshop. Bye bye everyone. Sir, thank you very much once again for your wonderful time and efforts towards this workshop. It's been like midnight there in California, I think. So like about 12:30, and your climatic description, like it's been too hot over there. So thank you very much. It's been a Friday evening for you, working all the week long, and then assisting us for the Friday evenings. It was very valuable for here people out in India. I have been a Google Cloud Ready facilitators previously for my college and all. I will spread the word for this coming up courses and the certifications you have been talked about. We are waiting for the slides and the material you have been teaching us on for this workshop. It's no worries, like we can share it later on for a few times. But overall, it was a great experience learning from you, sir.
Okay, thank you very much for having me. Thank you, everyone.
Thank you, sir. Thank you, sir.